what are some of the important aspects that we are going to cover in this session? So we have analyzed the last 10 to 15 years of the previous year questions and picked out some of the most important topics. 2009, right? It was asking what, right? So it was asking that in the core, which one of the following would you find? So it's a what based question. Now, if a similar question is seen, say for example in 2023, it is asking a particular what? Process base, right? So it is now focusing on process. What is happening here? What is P wave? What is S wave? And what is the consequence of it? So from what to process based question. Now the most important thing, asthenosphere is part of the mantle only, right? It is not part of the crust, right? So this is very, very important for you to remember. There is a very small mnemonics that you can remember. This is CMRGL, right? There are 5 major discontinuities that we can focus on. In case of sedimentary rocks, what is happening here? So here you will find sandstone, limestone, coal, etc. Now, coal is a very, very important sedimentary rock. Now, what is this terrestrial radiation now, right? Now, this is a particular portion that has been asked before in your UPSC exams in the last few years also. So in case of El Nino and La Nina, what are some of the basic things that you can remember? It is happening between which two regions? So it is happening between the South American coast and the Australian coast. What are some of the impacts of El Nino and La Nina on India? So this can be asked straightforwardly. Hello students, how are you all doing? I'm hoping that all of you are doing well, you're keeping well, your revisions are going very well. My name is Lalit Kishore Chaudhary, and today we are going to look at the score booster series for geography for, of course, the upcoming prelims 2026, right? Now in that regard, what are some of the important aspects that we are going to cover in this session? So we have analyzed the last 10 to 15 years of the previous year questions and picked out some of the most important topics, right? That is what we are going to look at. Now, we have taken these topics from all 3 or 4 the divisions of the geography section that is there in our syllabus. We are going to look at topics from geomorphology, climatology, oceanography, as well as Indian geography, right? So we are going to look at topics from all of these particular divisions. In that regard, what is the change that you have seen in UPSC question itself? So we are going to look at what is the change, the type of questions that has changed in the last 10 to 15 years also. You must remember that every single topic that you are going to see from the first to the last is an important one in our consideration. So if you are going to focus on a particular topic, there is of course timestamps that you can directly go to, but I would suggest that you sit through this whole session and it will be fruitful for your revisions. Alright. So if you look at the type of questions that UPSC is asking now, so this is question from 2009, right? It was asking what, right? So it was asking that in the core, which one of the following would you find? So it's a what based question. Now, if a similar question is seen, say for example in 2023, it is asking a particular what? Process base, right? So it is now focusing on process. What is happening here? What is P wave? What is S wave? And what is the consequence of it? So from what to process based question, UPSC has shifted towards process based question. Now the next important thing is that if the UPSC is shifting towards it, is it happening in a particular part of the syllabus or in all of the sections? So if you see another question, this was from climatology, right? A seasonal reversal of wind is typical characteristic of which of these climates? This is from 2014, so just 10 years back, right? Now, if you see a similar question with respect to climatology, see what is the type of question it is asking. This is from 2025 only, right? There are 3 statements, and then they are asking you which one of this is correct, right? If you look at again one of the next question from 2024, again there are 2 statements, and then they are asking whether which statement is correct, not correct, and what is the correlation between these 2 statements. So this is the type of question that they are asking repeatedly now, right? Now we will have to be prepared for it. So that is why the whole focus of this session will be on process based understanding also of these questions, of these topics. All right. In that regard, let's start with, we'll look at some of the PYQs also as we are doing these particular topics. So let's start with the interior of the earth. Now this is a very, very important section. there have been questions directly asked from this topic. Of course, one of the question we have already seen, right? So this was asked in 2009, that with the structure of the planet Earth, below the mantle, core is mainly made up of what element, right? Now, if there is a question from this particular section, you can expect questions from, say, for example, the sources of the interior. How do we come to know about these particular areas, right? How do we come to know ki, okay, this crust is having such and such aspects, and a mantle is having such and such aspect, and core is having such and such aspect, right? How do we know that there are divisions within these particular layers also, right? So there are direct and indirect sources. Direct sources are mining, drilling, and borewells. Of course, they will not be able to go as deep, but indirect sources such as seismic waves, even meteorites, because they are also giving us an indirect understanding of what kind of things that we might find inside our Earth. Magnetic field density, these are some of the different ways through which we come to know about our interior. All right. So these are direct and indirect sources through which we come to know about the interior of the Earth, right? Now, in case of the interior of the Earth, there are some broad divisions. I'm hoping that most of you would have heard about crust, mantle, and core. There are some subdivisions also. So in case of crust, there is oceanic and continental crust. In case of mantle, there is upper and lower mantle. In case of core, there is liquid outer core and solid inner core, right? Now, there are particular characteristics and compositions of all of these layers, right? You must have a basic understanding about all of these layers, right? We'll of course start with the first one, that is the crust. Now, in case of crust, two important layers would you find, or two important subdivisions would you find, right? There is a continental crust, there is an oceanic crust. Continental crust is thicker, right? Oceanic is thinner. Hence, their density will be lesser. Here, more density will be there because a lot of volume is comprised in a very small cross section, right? So it is more denser, it is less denser, it is thicker, it is thinner, right? Next important aspect, what are they composed of? So they are composed of silicate and aluminium in case of continental, and silicate and magnesium in case of the oceanic crust. Is this clear? Right? No issues till now. Now, it is floating over asthenosphere, right? Now, what is this asthenosphere? So, if you look at the asthenosphere, it is a partially molten, partially molten zone, right? Where you would find magma. So, it is in this layer that magma is there, and this is the main source of magma for us, right? It is also the layer over which tectonic plates are floating. So, the crust is the outermost layer supporting all life on Earth, right? It is having a thickness of how much? So, this is 40 kilometers, right? So, this crust is 40 kilometers thick, right? And lastly, it is floating over asthenosphere. We have already looked at asthenosphere. Now, we move towards the mantle portion. Now, the most important thing, asthenosphere is part of the mantle only, right? It is not part of the crust, right? So this is very, very important for you to remember, that when we are talking about asthenosphere and the tectonic plates floating over it, this is part of the which section? Mantle. Now, in case of mantle, what are some of the important aspects? So if you look at this particular diagram, you can easily see that this is of course the middle layer, right? But the most important thing is, it is making up the most amount or the largest volume of the Earth's interior, right? This is a very crucial aspect, that which layer is comprising the largest volume of the Earth's interior? It is the mantle, right? It is almost covering more than 80% of the Earth's interior, right, by volume. Okay. What is the thickness? So from 40 to 2900 kilometers, you will find the mantle, but there are some divisions. There is upper and lower mantle. Now, in case of mantle, the next important aspect would be that after this particular section, that is the lower mantle, you will move towards the outer core and then the inner core. Now, there are these discontinuities that we are going to look at after we have looked at these particular layers. Now, as we move towards the core, there is a very important change that is happening. So, till here, it is mostly solid, right? From here till here, it is mostly solid. Of course, there is partially molten asthenosphere in between, and there are some sections, but mostly solid. Now, very interesting thing is happening in case of the core. Now, this is the innermost layer of the earth, right? It is very, very hot in there, right? In that case, what is happening in case of this particular layer is going to affect all of the other sections, right? Now, here what you will find is in case of the core, there are two major divisions, the outer core and the inner core. Now, if you look at from 2900 kilometers to the center of the earth, that is 6371 kilometers, there is this whole cross section that is comprising the core, right? Now, if you look at this particular cross section, there are two divisions. So, from 2900 to 5150, there is the outer core, and then from 5150 to 6371, there is the inner core. The major difference is that outer core is liquid in character and inner core is solid in character, right? It's a very important aspect. Now, the core overall is made up of nickel and iron. That is something very basic that I'm hoping that you know about. But if you look at their own compositions, so there is a difference. Here, in case of outer core, the elements that you will find is silicon, sulfur, carbon, oxygen, except of course nickel and iron, too they will be there. But in case of inner core, you will find solid iron, you will find solid iron with little amounts of nickel, right? So there are some differentiations even in composition between these two layers. Now, the next important aspect is if there is a liquid outer core, right? So this solid inner core is suspended in this liquid outer core, right? And what will be the effect that it will have? So the outer core is responsible for the Earth's magnetic field, right? That is very, very important because of its liquid character. We see that the Earth is having its own magnetic field. It is having a very direct effect around us. Now, I'm hoping that you must have an understanding that this magnetic field is very important for our own security and safety. And it is this magnetic field allows life to sustain on Earth, right? Now, the next important aspect is this particular core is the force behind the Earth's rotation as well as the current that is flowing inside the Earth, right? So it's a very, very important aspect, right? So it is directly responsible for Earth's rotation. It's directly responsible for Earth's magnetic field. Very important cross sections. All right. Is this clear? Is there any doubt till here? Right. So we have seen the broad divisions. Now we are going to look at the discontinuities. Now in that regard, there is a very small mnemonics that you can remember. This is CMRGL. Right. There are 5 major discontinuities that we can focus on, or these are discontinuities, or you can say boundaries between these layers, right? So if we start from the crust region, so between the upper and lower crust there is Conrad. Then there is from between lower crust and upper mantle, right? As we move towards the mantle region, there is Moho, right? Then, or Mohorovic, if you look at the full meaning. Then if from upper to lower mantle, there is Repeti. From lower mantle to outer core, there is Gutenberg, and from outer and to inner core, there is Lehmann, right? If you are able to remember this particular diagram, it will really help you remember if there is any question regarding these discontinuities. So crust, Conrad, then as we move towards the mantle, Moho, then between the two mantles, there is Repeti, then lower mantle to outer core, there is Gutenberg, and then from outer and inner core, there is Lehmann. These are the boundaries between these divisions, right? Now, this is a very basic revision of this particular section. Now we will move towards the important section that is for us especially, that is the plate tectonics, and there we will look at the earthquake and the volcano sections, right? Now, how has our own landmass evolved? So if you know that this whole region is a very dynamic place, right? It was at a point of time we considered that there was a huge supercontinent by the name of Pangaea, right? That got divided into Laurasia and Gondwana land, right? And from this Gondwana land, our Indo-Australian plate separated and moved towards the Eurasian plate, forming the Indian subcontinent, right? So this is a basic idea, that India was somewhere here and we moved towards this Eurasian plate and formed the Indian subcontinent, right? Now, because it is such a dynamic place, then what will is happening here, and how is it moving? All right, so we know about these particular supercontinent, Laurasia, Gondwana land, how Indian subcontinent came about. Now what we are going to do is we are going to understand this process. Why is it happening? What is the most important contributor to the dynamism of these tectonic plates? We know that these plates are made up of rigid lithosphere, right? That is the crust and upper portion of the mantle that is floating over which particular region? It is floating over the asthenosphere, right? Here in this particular region, you will find convectional currents, right? These convectional currents are moving in a particular direction that is causing the plates to move, right? So if you have to have a basic understanding, what is the reason that plates are moving? It is the convectional current that is causing the plates to move in horizontal region, right? So horizontal would be this way and vertical would be this way. These convectional currents are making the plates move in the horizontal movement, in the horizontal direction. All right. So is this process clear? That these plates are floating over the asthenosphere where you would find convectional currents that is leading to the horizontal movement of the plates. Now, when we are talking about these plates, there will be different types of plate interactions, right? In that regard, what are the different types of plate interactions? What are the different types of plate boundaries that you will find? So there is divergent boundary where two plates are moving away from each other. Now, as they are moving away, new crust is being formed, right? Then there is convergent boundary. So two plates are colliding here, and then there is transform boundary. They are scraping against each other, but neither they are colliding, neither they are moving away, right? Now, in that regard, what are some of the basic things? So the first important thing that you will have to remember is where new crust is being formed. This new crust is being formed in case of divergent boundary. When two plates are moving apart from each other, new crust is formed, right? Next, in case of convergent boundary, which plate would go down, which plate would go up, right? That there you will have to remember the density aspect, right? So thicker plate, that is less denser. So in case of continental and oceanic crust, right, what we had seen was which was much more thicker. It was the continental crust was more thicker, hence less denser. So thicker plate overrides the thinner plate. That is meaning what? So if this is the thinner oceanic plate, the thicker plate is overriding it. ये ऊपर चला जा रहा है ना? The more denser plate is going downwards, right? This is a very, very important aspect. So thicker plate moves up, thinner plate moves down, right? This is happening in case of convergent boundary. Now, this particular boundary is where crust is destroyed, right? In case of divergent boundary, new crust was created, right? In case of convergent boundary, because two plates are colliding with each other, the crust is destroyed here, right? Now the last one, that is transform boundary. So here plates are scraping past each other and neither crust is being created nor destroyed, right? This is a very important demarcation. First, in case of plates moving apart from each other, new crust is formed. In case of plates colliding with each other, what is happening? Crust is being destroyed, and when this collision is taking place, the thicker plate is doing what? Because it is less denser, it is moving up, and the thinner plate that is more denser is moving down, right? And in case of transform boundary, it is neither crust is being created nor destroyed. Is this clear? Right? Now, if we have a basic understanding about these plate interactions, now we can move towards the particular section that is related to earthquakes, right? Because that is one of the most important aspects with respect to plate boundary interactions. Now, in case of earthquakes, what are some of the basic things that you know? So, it is what kind of activity is it? So, here it is a vibration that is being caused, right? It is a vibration of the what particular section? So it is a vibration of the surface of the earth, right? Here basically the earth's surface the crust is shaking here, right? Now, due to this shaking, a very important thing is happening. It is leading to a sudden release of energy, right? A sudden release of energy is happening, due to which these seismic waves are going towards in all directions, right? It's a very important aspect of this particular area. Now, they are called seismic waves. From there only you will find the term called seismology, which is a branch of science that studies this kind of activity, right? Now, here two terms are very important. There is, like, whenever you are hearing about earthquakes, you will find focus and epicenter, that is frequently being seen in case of these earthquakes, right? So, let's see what is this focus, what is this epicenter. In fact, there is a possibility that they might use the term hypocenter and epicenter, right? What is happening here? So, say for example, if these two plates are colliding with each other, right? The point where this particular activity is starting from, right? That is the focus, that is the hypocenter. So, this is the point inside the earth from where this sudden release of energy is happening, right? And exactly perpendicular to it and on the surface of the earth, where there will be, or the shortest distance from the फोकस है ना, परपेंडिकुलर डायरेक्शन में अपने सरफेस ऑफ द अर्थ में, जहां पे आपको क्या देखने के लिए मिल रहा है कि दिस इज द पॉइंट क्लोजेस्ट टू द फोकस ऑन द सरफेस ऑफ द अर्थ, दिस इज कॉल्ड द एपिसेंटर, राइट? सो इन केस in this particular diagram, if you see, this is the focus and this is the epicenter. Epicenter is on the surface, hypocenter or the focus is the point where the sudden release of energy is happening. All right, this is a very important demarcation. You must remember this. All right, next is, now generally speaking, whenever we are talking about earthquakes, we mostly consider it in case of tectonic movements. But are there other causes through which earthquakes can happen? So there are. It can be caused due to volcanic activity. This is something that we have seen even in the past also, right? Then even human activity can cause earthquakes, especially if there is nuclear explosions. Even dams can cause earthquakes, right? So that is a very important aspect, right? That even human activity is able to cause earthquakes. Then there would be areas that are subduction zone, right? The faults on the earth's crust that can also cause earthquakes. So it is not just natural, it can be human also, है ना? It is a very important thing that you must remember. Now, where would you find these earthquakes happening, right? What is the area where would you find most of the earthquakes is happening? So most of the earthquakes is happening in the crust and upper mantle region from 0 to 200 kilometers, right? From 0 to 40 was the crust region, and after that there is upper mantle region. So most of the, all of the earthquakes, in fact you can mark it out that all of the earthquakes originate in the lithosphere region of which particular area? 0 to 200 kilometers, crust plus upper mantle region, right? This is a very important aspect because this can be asked as a statement also, right? That all of the earthquakes is happening in 0 to 200 kilometers. That is actually correct. All right. So there can be human causes also for the earthquakes, and these are happening in a particular region that is from 0 to 200 kilometers. Is that all right? Is it clear till now? Is there any issue till now that you are not clear about? You can also ask these particular aspects. If it is clear, then we can move towards a particular and a very important section, that is P waves and S waves, right? Body waves, surface waves, and specifically we will look at the P wave and S wave because this has been asked in previous years also, right? So we will move towards the type of seismic waves. Now, in case of seismic waves, there are two kinds of waves. One is body wave, the other is the surface wave, right? Body waves are known by the term body waves. Why? Because they are traveling through the body of the earth, right? They are traveling through the body of the earth after being generated at the focus, and they are radiating in all directions. But in case of surface wave, here when the body waves are interacting with the surface rocks, they are giving rise to the surface waves. So very important demarcation. So in case of the body waves, what is happening? So two plates are colliding, say for example, right? Then there is a sudden release of energy and this is leading to the body waves. Now, as these body waves are reaching the surface of the earth, it is interacting with the surface rocks, and then surface waves are happening, right? Now, where would you find the P wave and S wave, right? Because this is a particular section that you have to have a good understanding about. So whenever you are talking about P wave and S wave, we'll come to the PYQ later. So whenever you are talking about P wave and S wave, these are the body waves, and that is why we are saying that it is traveling through the body of the earth, right? Now, what are some of the basic aspects with respect to primary and secondary wave, right? So both of them are body waves, both of them are traveling through the interior of the earth. But in case of primary wave, it is moving faster, right? It is moving faster because it is able to travel through all the mediums, right? It is able to travel through solid medium, it is able to travel through liquid medium, it is even able to travel through gaseous medium, right? That is why this is the wave, that is first to reach the surface of the earth, right? That is why primary. Now, in case of secondary wave, what is happening? So, it can only pass through solid mediums. So, there will be a huge shadow zone, right? In case of secondary wave, the shadow zone in case of primary wave is quite a bit less, right? It is between 105 degrees to 145 degrees. But in case of secondary wave, it is a huge area. So, from 105 to 105 degrees, there is a huge area, that is the shadow zone, where you will not be able to feel these secondary waves, right? Why? Because they are only able to pass through solid materials, right? And you know that there is a liquid outer core, so it is not letting them pass. Because primary waves are able to pass through this liquid outer core, they are able to reach the surface of the earth. And next important aspect is that they are coming after a time lag, right? They are able to reach the surface after a time lag. But because they are not able to pass through the liquid outer core, that is why we know that there is a liquid medium that is there inside, that is not letting them pass, right? So it's a very important aspect that primary and secondary waves are very different in their own way, right? Now, all right, so this was a basic differentiation between primary and secondary wave. Now, what are some of the basic things? Which is faster? It is the primary wave. Which is able to travel through all the medium? It is the primary wave. Which is able to reach the surface first? It is the primary wave. But because secondary wave is not able to pass through liquid medium, right? Then only we come to know that there must be a liquid outer core inside the earth, right? Now, in that regard, the next question would be, which of the two is more destructive one? So here you will have to remember that it is the secondary wave that is more destructive than the primary wave, right? What are the reasons? So because of this kind of movement of the secondary wave and how the structures over the surface of the earth are responding to that particular movement, iske karan it is properly shaking up the structures, right? So that is why it is more destructive. So which among the two is more destructive? It is the secondary wave that is more destructive, right? It's a very, very important aspect. If you have to remember, if you want to have a basic analysis of these two aspects, so there will be a particular comparative analysis of these two waves. You can take a look at it, and you can pause it here and take a look at it, right? So primary waves are longitudinal in character, secondary waves are transverse in character. So here it is almost like it is pushing you, right? And secondary waves are shaking you, right? Speed, primary waves are faster and secondary wave are slower, right? Which will arrive first to the surface of the earth? It will be the primary wave, and a secondary wave arrive after the primary wave, right? What is the medium here? So all mediums, it is able to travel through all the mediums. Secondary wave is only through solid medium, right? And which is more destructive? Their secondary wave is more destructive. The next important aspect with respect to secondary wave is that here also it is through these waves that we have a basic understanding that there must be a liquid medium inside the interior of the earth. All right. Now, the next important aspect is with respect to the distribution. In that case, you will find a global distribution of these regions where a lot of earthquakes are happening, and around these regions only there are a lot of volcanic eruptions also happening, but we will look at them properly. So the first important region would be this region around the Pacific, right? This is also known as, I'm hoping that you would know that there is a Pacific ring of fire, right, that you have heard about. So there a lot of volcanoes are also there, and in this particular region only you will find a lot of earthquakes that is happening. Why? Because the number of plate interactions is happening in this particular region, right? So there is a circum-Pacific belt that is among the most active regions of earthquakes in the world. Next one is the mid-Atlantic belt, right? Again, here you will find which are the plates that are involved here. So there is North American and South American plate, right, in this particular region, and then in this region there is the Eurasian plate and the African plate, right? It is because of the interaction of these four huge plates that the region of this mid-oceanic belt is very important with respect to earthquakes. Next important aspect would be, now this we know that this region of Africa, the Eastern African region, is splitting apart, right? Now because of this particular movement, here you will find this is the East African Rift Valley, right? Here it is splitting apart. Hence what you will find here is there is a lot of earthquakes that are happening in this region. And of course our region is coming in the mid-continental belt. It is running from Spain and Portugal till the Southeast Asian regions, right? So here what is happening? The Eurasian plate is colliding with the African plate, and it is through this particular interaction, and of course Indo-Australian plate, through this particular interaction that you are going to find this particular region, the mid-continental belt, that is an active earthquake zone region. In case of India, what are some of the important regions? So there has been a recent updation, right, with respect to zonation, and you can remember that there are lot of our regions, especially in the north, that are in very high vulnerable region, that are coming in the very high vulnerable regions. Then there is the region with respect to where you will find the Bhuj earthquake that happened in the early 2000s, right? The next area is Andaman and Nicobar region, right? This particular Himalayan region too we know because here Indo-Australian plate is colliding with the Eurasian plate. So this is the region for this particular vulnerability. In case of Andaman, it is a very high vulnerable zone, right? Here only tsunami of 2004 happened, right? And then the other one is the Gujarat area where Bhuj earthquake has happened, right? Otherwise, there are other regions also that are important, but these three are the most vulnerable regions of India, right? Is this clear here till now? Is there any issue till now that is not clear? All right. Now we will look at this Pacific Ring of Fire. Why is it so important? Because this is around the Pacific, right? Now again, which are the plates that are involved here? So there will be South American, North American plate, Eurasian plate, Indo-Australian plate. These are the major plates. Otherwise, there are also smaller plates also there. But these are some of the major plates that are involved here. A lot of seismic activity again is happening, right? So here you will find a lot of volcanoes and a lot of earthquake regions, earthquake activity going on. How much? So it is this particular circum-Pacific belt is accounting for over 50% of the seismic activity of the earth, right? So if there are two earthquakes happening on earth, at least one of them is happening in this particular region, right? Now why is it that it is such an active region? So here different plates are meeting, right? It is a huge area, right? Pacific in itself is a huge area, and it is comprising a lot of big continents, big plates that are constantly interacting with each other, right? So North American, South American, Indo-Australian, Eurasian, these huge plates are interacting with each other. Hence a lot of seismic activity is going on, and here you will find both earthquakes as well as volcanoes in huge numbers, right? Is this clear? All right. Now we are talking about earthquakes. We have talked about convectional currents. So let's see first of all, before we move on to the convectional currents, let's see a question in this particular section that has been asked before. Let's see how many of you are able to answer this after reading through, after going through all of these, understanding all these basic ideas about this particular topic. Let's see. All right. Is it clear? Right. Now we have talked about convectional currents. That is the reason for the dynamism of the Earth, right? That is the reason that tectonic plates are moving about, right? That is the reason that plate interactions are happening. So we must have a basic understanding about the different aspects of this particular convectional currents. What are they? How are they moving, right? So we'll look at convectional currents now, right? I'm hoping that till here you are able to interact with these topics properly, you are able to revise these topics properly, you are able to do interconnections between different topics, right? Now we will look at the convectional current. Now what is it? The first of all, what is it? So it is a circular motion of semi-molten material inside the earth. Where is it happening? It is happening in this mantle region, right? So it is a circular motion of semi-molten material inside the mantle, right? Which is this particular part of the mantle? It is of course the asthenosphere, where you will find this semi-molten material, where it is moving about in this particular direction. Now how is it happening, right? So above the asthenosphere there is crust, you know, it is trying to push, you know, it is trying, its all the force is pushing it downwards, and we know that from the inside of the earth there is heat coming up, and you know a characteristic of heat, that it is pushing up. So this crust is pushing down, the heat is pushing up, due to which this movement of the crust is happening, right? Movement of the heat is happening inside the earth in a circular motion, right? Now if you look at this whole process, we'll go step by step. So there is heating from inside the earth, that is leading to the upward movement of this heat, है ना? This heat is moving up, but ऊपर में आपको क्या देखने के लिए मिला कि there is a crust that is pushing itself downwards, right? Now as it moves up, there will be some cooling near the surface, right? As it moves up, there will be some cooling, and due to this cooling, you know that these kind of in these kind of interactions, any fluid, right, from tries to move from high pressure to low pressure regions, right? This is a very basic characteristic. If you have even pushed a say for example even some rubber balls also in your society, or when you were small, right? So you would find that wherever you are pushing a lot, like you are applying a lot of pressure, it is trying to escape towards regions where there is low pressure. ये हम लोगों के साथ भी होता है. Even as students, we try to find where there is less pressure, less competition, right? Unfortunately, that is not the case with UPSC. So हम लोग को यहाँ पे इसको जो है ना, we are going to face this high pressure environment in just a few days. But generally speaking, fluids move from high pressure to low pressure regions, right? Now it will cool near the surface as it moves up, right? And as it cools, it will sink downwards, right? So as it cools, it will sink downwards, and then again it will get heated up, it will rise again, then slowly and slowly it will cool and then sink downwards, फिर again it will go on in this particular region. These are the convectional currents that are happening in the asthenosphere, right? In this asthenosphere, leading to the horizontal movement of the crust. Is that all right? Right? It's a very, very important section, right? Convectional currents. Then as we move towards the volcanism portion, there also you will find that these particular aspects are very important, right? In case of volcanoes, what are some of the basic things that we know, right? Now, I'm hoping that convectional current is quite a bit clear to you now. So there is this circular motion of semi-molten material that is happening in the asthenosphere, leading to the movement of the tectonic plates. It is leading to earthquakes, it is leading to volcanic activity, right? These are due to this plate interaction only, and this plate interaction is happening because of this convectional current, right? It is leading to formation of mountains and ocean basins, right? These plate interactions. It is leading to the magma that is reaching the surface of the earth, right? It is creating mid-oceanic ridges that we are going to see in just a few minutes, right? So all of these are consequences of coming from the convectional currents that are happening inside this interior of the earth. All right, is this particular process clear? So there is heat from the inside, it is moving up, right? As it moves up, it will slowly and slowly cool down. As it cools down, as it cools down, right, it will sink downwards. Again, it will get heated up, and this whole circular movement keeps on happening. All right. Next important region that we are going to look at from our syllabus is the volcanoes, right? Now, I'm not going to look at it in a very basic detail, because I'm hoping that you know that what is a vent, what is a crater, right? These are not some things I'm hoping that you know about lava, you will know about these things. But there is a particular term that you might have heard, but not focused on as much. That is a possibility that UPSC might use it in one of the questions or as answers, right? So, all of these basic things I'm hoping that you would know, that there is a crater at the top, right? There is this vent through which magma is able to rise up. There is a magma chamber from where magma is taken up, by the volcanoes, right? It is having all different things like lava, steam, ashes, everything that is coming out of these particular regions, right? This is a very basic aspect. Now, the important thing that you can remember is the pyroclastic flow, right? I'm hoping that you know that there is a vent, right? This is the region of the volcano from where magma is able to rise up, right? Now, as magma is able to rise up, right, it is exploding, right? And this explosion brings with itself mixture of hot gases, ash and other volcanic rocks, right? It is the one of the most dangerous parts of the volcano, right? Because these solid and semi-solid fragments then flow down the slope of the volcano, right? Especially if there are any human habitations in that particular region, it is the pyroclastic flow that is very, very dangerous for them, right? So, this is very, very important that you must have an understanding that what are these pyroclastic flow. It is a mixture of hot gases, ash and other volcanic rocks. Can anyone tell me how are volcanoes formed? What is the basic idea behind the formation of the volcano? How are they formed? Why is it that in some particular regions you will find a lot of volcanoes and in some particular regions there are no volcanoes, right? So, basically what is happening is we know about the movement of the tectonic plates, right? Now, as the plates are interacting with each other, they are going through a process of subduction, right? So, there is a collision, right? There is one plate is subducting, other plate is moving up. Which is the plate that is moving up? It is the thicker plate, less denser plate that is moving up, and the thinner and more denser plate is moving down. This particular subduction is causing what? It is causing fractures in the Earth's crust, right? And through these fractures, the magma is able to come out, right? That is the basic idea behind volcanoes, all right? It's a very, very important aspect. That is why we have seen that in the same region where you will find a lot of seismic activity that is going on, in that same region you will find a lot of volcanic eruptions that are happening, right? Now, volcanic eruptions need to have magma chamber that is full of magma. There is a chance that there are possibilities when the magma chamber is empty, the volcanoes are not having eruptions or very violent eruptions, right? So, these are some of the basic idea behind volcanoes. I am hoping that you have a good understanding about them. This has been asked before, it can be asked again. Now, the next important aspect is, okay, see for example, in India, there is only one active volcano. And in many parts of the earth, there you will find dormant volcanoes. There are some extinct volcanoes also, right? So, what is the difference between an active volcano, a dormant volcano and a extinct volcano? Now, in this regard, there are basic, like there are other aspects also, but basically there are three important things that you can remember. It is this particular thing, that if a volcano has erupted in the last 10,000 years and it is likely to erupt again, because if there is magma is still in its magma chamber, then it is called an active volcano. If a volcano has not erupted in the last 10,000 years but is likely to erupt again, because again there is magma in its magma chamber, then it is called a dormant volcano, that it might erupt again. The time period is 10,000 years. It's a huge time period, right? In case of extinct volcano, there are no eruptions within historic time that we have any idea about, and it is unlikely to erupt again. So, in both of these cases, in active as well as dormant volcanoes, there is magma in the magma chamber. In this case, we feel that they are unlikely to erupt again, because it seems like their magma chamber is empty now, right? That is a very, very important aspect. So is it likely to erupt again? And if it is likely to erupt again, how much is the time period that we are taking? It is 10,000 years. Whether it has happened in the 10,000 years, then it is active, and if there is still magma left, then it is active. If it has not happened in the 10,000 years, then it is dormant but is likely to erupt again. In case of extinct, it is there is no eruptions has happened in the historic time period and it is unlikely to erupt. So that is the difference between active, dormant and extinct volcanoes. All right. Next is the aspect with respect to volcanism, right? Now, because volcanoes are a very, very prominent part of our landscape. So when they are erupting, they are causing changes in our landscape, and they are causing changes in our Earth's crust, right? In that regard, which is the particular activity that is known as geologic architect, right? If this is a question, that which of these is known as a geologic architect? Is it earthquake? Is it pyroclastic flow? Is it volcanoes? There can be other very similar sounding names also. It is actually the volcanoes that are known as geologic architects. Why? Because it is the volcanoes that have created more than 80% of the Earth's surface. So it is volcanoes that have created more than 80% of the Earth's volcanoes. This is very, very important for you to remember. This can be easily asked as a statement from geomorphology, right? They lay the foundations for life to thrive on Earth, right? And it is present in every continent. So in every region of the Earth, you will find volcanoes present, and they have had an effect on their surrounding area. They have had so much of an effect that they have created more than 80% of the Earth's surface. Now, how are they creating these surfaces? So when this magma is able to come out, right, slowly and slowly it will cool down, right? When we are looking at when we are doing the rock cycle, we will see that slowly and slowly it will cool down, it will solidify and then become the igneous rocks, right? Then from there it will move towards metamorphic and then sedimentary rocks, sedimentary and metamorphic rocks. So when we are going to look at the rock cycle, we are going to see them properly. But it is a very, very crucial aspect that it is the volcanoes that are known as geologic agents, because they are having an effect around the area and they have created more than 80% of the Earth's surface, right? Now, in case of volcanoes around the world, there are over 1500 active volcanoes, right, around the world, right? 75% of which is in the Pacific Ring of Fire. So again, that is a particular region that is very, very active with respect to volcanic eruptions. 75% of our active volcanoes are in the Ring of Fire itself. Some examples would be some Hawaiian volcanoes are there. Mount Krakatoa is very important. Mount Fuji in Japan. Mount Etna is there. Barren Island, of course, in India is there. Right? Some of these examples would be there. In that regard, now let's look at the different types of volcanoes. This can be asked straightforwardly from you, right? So there are some major types of volcanoes. We are going to focus on three. First is the shield volcano. Now, what you can remember about shield volcanoes? It is the largest of all volcanoes, right? Now, one of the example would be Hawaiian volcanoes. Now, Hawaiian volcano is not around a particular region where there are plate movements that are happening. It is right in the middle of the Pacific plate, but still because of hotspot volcanism, this is having a particular the type of the volcano is shield volcano. It is largest of all volcanoes, but we are not saying it is the most explosive. We are saying it is the largest, right? Now, in case of composite volcanoes, here what is happening is there are different layers of solid magma mixed with layers of sand and gravel, right? So there is composite, है ना? यहाँ पे there are layers and layers of magma that are mixed with sand and gravel that is forming these kind of volcanoes that are called composite. Composite meaning there are a lot of materials have combined together to form these kind of volcanoes. Now, again, it is explosive, but not as explosive as the third one, that is the caldera. This is the most explosive volcano, right? Here, the magma chamber is very, very large and it is closer to the surface. So, the largest volcanoes are which one? It is the shield volcano. Composite is a mixture of a lot of things, especially magma, sand and gravel, right? It is also quite explosive, but the most explosive ones are the calderas, where magma chamber is very large and it is very close to the surface of the earth, right? So, these are some of the important aspects. Otherwise, these particular terms, that cinder cone volcano, it is small volcanoes, right? Next one, the flood basalt provinces. Now, this is a very interesting one because it is through this particular type of volcano that we have seen a particular area of our earth, of our Indian subcontinent, that is the Deccan traps that have formed, right? So, Deccan trap is formed due to what? So, as the Indo-Australian plate was moving towards the Eurasian plate, right, it passed through a particular region in today's Indian Ocean where there was hotspot volcanism that was happening, right, as is the case with Hawaiian volcanoes. Now, the lava that got out, it spread itself almost like a flood, right, and as it solidified and as it cooled down, it created our Deccan trap, where you would find a lot of black soil, right, where you would find a lot of cotton production that is happening, right. So, they are a type of volcano known as flood basalt provinces, right. And the last one that we can remember is the mid-oceanic ridges, right. Now, in the name itself, it is mid-oceanic. So, they will be in the oceans, right. They will be underwater. So, these are underwater volcanoes, right. Now, if you remember, the divergent plate boundaries were creating new crust. This is the new crust that is happening here. So, when the two plates are moving apart from each other, the new crust is being formed, that is known as mid-oceanic ridges. This, of course, one of the examples is in the mid-Atlantic ocean region, right, where again you had seen that one of the major sections of seismic activity you had seen, right. So, here as the plates are moving apart from each other, the new crust is formed, and this new crust is, and how do we know this? So, if you look at the age of the rocks in the middle portion, it is much newer than the age of the rocks if as you move further apart from the middle section, right. So, we know that this is a new crust that is being formed due to the divergence of the plates, right. Here, of course, eruptions happen frequently, but generally around the central portion of the region, right. And because of these eruptions, what will happen? It will again slowly and slowly solidify, it will slowly and slowly cool down and then form the new crust. This is the way through which most of the Earth's surface has been formed, right. So, that is why we told them that volcanoes are called geologic architects, right. It is through this particular kind of activity that they have created all of this landmass, right. So, what are some of the basic processes involved, right, because it's not just that you must have a basic understanding of what is it, but also how is it happening. So, first of all, there is a gradual rise in temperature, right. Then there is formation of gas and vapors due to heating, right. Then as magma comes up, there is volcanic eruption that is happening. Now, after the volcanic eruption, there are a lot of things that are happening. Among them, one of the most important thing is the pyroclastic flow, that you can remember. What is it? It is a mixture of, what are some of the basic things? Hot gases, ash and volcanic rocks. With respect to the activity status, active volcanoes are 10,000 years they would have erupted and they are likely to erupt again. They have not erupted in 10,000 years but are likely to dormant and extinct. They have not erupted in historic times and unlikely to erupt because most probably their magma chamber is empty. So, we have looked at the types. Now, we will look at the minerals and rocks. Now, in case of minerals and rocks, what are some of the important aspects? So, first of all, we will take a good look at, or we must have an understanding about the difference between an element, a mineral and a rock, right. From there, you will move towards the rock cycle and then we will understand the difference between the three major types of rocks. Now, in case of elements, what are some of the basic things? So, this is the basic building block of matter, right. I am hoping that you would have heard about the periodic table of elements, right. Why do we study it? Because it is at the very core of it, right. At the very basic unit of it, you will find these elements. In the Earth's crust, 98% 98% of the Earth's crust is composed of 8 major elements. Which are these elements? These are aluminium, iron, oxygen, calcium, sodium, potassium, magnesium, silicon, right? So, the crust of the Earth, not the whole Earth, but the crust of the Earth is composed of these 8 elements. Now, when two or more elements come together, they will form minerals, right? So, when two or more elements, generally speaking, it is two or more. There are some elements, there are some minerals that are also having single element, but when generally speaking, when two or more elements are coming together, they are forming mineral, right? This is a basic aspect that you have to remember, right? Now, what is the characteristic of minerals? So, they have an orderly atomic structure and definite physical and chemical composition. This is a crucial aspect that you will have to remember in comparison to rocks. It can come as a statement that which of these have an orderly atomic structure and definite physical and chemical composition, because it is here that you will find the differentiation from rocks and minerals, right? So, when two elements are coming together, they are forming what? Minerals, right? In that regard, what is the next important aspect? That there are, in some very rare cases, single element minerals also, such as gold, silver, copper, etc., right? So, generally speaking, it is two or more elements, but there in some cases there are also single element minerals also are there, right? Overall, in our current estimation, there are more than 2000 minerals that have been found and identified, right? So, it is a very important section that you can expect if you are looking at it from the science and tech background also, if you are looking at it from the geographical background also, that minerals are very important. They are made up of elements, right? And they have a definite physical and chemical characteristic, right? They have a definite physical and chemical composition, and more than 2000 of them are there, right? Now, in that regard, you would have seen, when especially we are looking at the resources section, there you would have seen that there are metallic minerals, there are non-metallic minerals, right? So, metallic, of course, there will be metals. So, there will be either precious metals, there ferrous or non-ferrous. And precious may, of course, gold and silver, ferrous may, iron and other ferrous elements, and then non-ferrous would be copper, lead, tin, etc., right? In case of non-metallic minerals, here you would find sulfur, phosphates, nitrates, and other such kind of elements, right? So, these are some of the basic aspects with respect to minerals. Now, as we move towards rocks, here you will find the crucial difference from the minerals. So, they had a definite physical and chemical composition. Rocks do not have a definite physical and chemical composition, right? So, they can be hard, they can be soft, they can be of different colors, right? They are not having a distinct physical and chemical composition, right? So, elements were forming minerals, two or more minerals are forming rocks, right? So, generally it is an aggregate of one or more minerals, right? So, in that case, elements, then minerals, then rocks, all right. Now, the study of rocks, or this kind of study of science of rocks, is known as petrology, right? So, that is why when we say petroleum, what is it? What we are talking about? It is coming from rocks, right? And which is the rock where you will find petroleum? This becomes a question, especially this year, because of all the fuel crisis that is going on, because of the Iran war that is going on, right? So, these are some of the things that you can associate even from the IR section also, right? Now, in this case, there is different aspects that we have seen with respect to rocks. What we are going to focus on, the first important aspect would be the rock cycle, that how rocks are created, right? Where do they start, and what are the different major characteristics that you will find in the particular rocks. Now, in that regard, it starts with, and it will always start with, magma, right? It will start with magma as it is coming up, right? Especially through the volcanoes. That is why we said that volcanoes are geologic architects, right? 80% of the surface of the earth is created by these volcanoes. And how is it that they are happening? So, these magma is able to rise up, right, through the volcanoes, and then slowly and slowly, as it moves out, it is getting solidified, it is cooling down, right, leading to what? Now, the formation of the igneous rock, right? So, from this magma, there will be igneous rock after solidification and condensation. Next, now this igneous rock will face weathering and erosion. There will be sediments that will come apart, right? So through this weathering and erosion, there will be what? The next aspect would be that after a lot of weathering and erosion that has happened, you will find that there is, just a minute, all right, let's see from here itself. Although I could have shown you the flow chart with respect to this particular section, we'll come to that. Right now, as a lot of weathering and erosion is happening due to the natural elements, say for example, rainfall is happening on these igneous rocks, the sediments are coming apart, right? Now, these sediments are then getting transported and then finally they are getting deposited in a particular region, right? Those are the sediments, right? As sedimentation is happening layer by layer, sediments are depositing in a particular area, they are forming sedimentary rocks, right? Now, after this sedimentary rock, what will happen is these sedimentary rocks under the pressure and temperature, under the effect of pressure and temperature, you will find that they are being transformed into metamorphic rocks. And when this metamorphic rock is then again subducting, they are forming magma, leading to again this whole cycle going on, right? So it's a very important aspect. Now, if you have to remember, you can remember it through this particular diagram. So you will always start with which particular section? So it will always start with magma, right? This magma is coming out through solidification and condensation, it is forming igneous rock, right? These igneous rock after weathering and erosion is forming sediments, right? After these sediments are depositing in a particular area, layer by layer, through lithification, they are becoming sedimentary rocks. Under heat and pressure, these sedimentary rocks or the igneous rocks then are transformed into metamorphic rocks, and then as this metamorphic rock subducts, right, it will again melt and form magma. So this rock cycle will go on. Now, if you look at a very complex flowchart, so you will see that this whole diagram is now having interconnections also, right? So igneous rock under heat and pressure can also directly be transformed into metamorphic rock. It doesn't have to be that sedimentary rock needs to be there, in between, right? Sediments, if you are seeing here the sediments that are going formed, even metamorphic rock under weathering and erosion will form sediments and then will form sedimentary rock. So it is a much more real world example. This is for our own remember it, for our own recall in the exam, but this is actually what is happening, right? So it starts with again magma, it is cooling, right, and solidifying to form igneous rock. If it is under weathering and erosion, it will form sediments. If it is going under heat and pressure, it is going to form metamorphic rock. This sediment is then having what? So there is lithification going on, compaction going on, cementation going on, and then it is forming sedimentary rock. This again, heat and pressure, it is forming metamorphic rock. Finally, so after subduction, after going inside the earth, right, it is melting to form magma again. So this is a basic idea of the rock cycle. It starts with, always starts with magma that will form igneous rock, right? This under heat and pressure, metamorphic, and under sedimentation, weathering and erosion, it will form sedimentary rock. This is a basic idea, right? If you look at some of the examples of these rocks, and some of the major differentiations, right? So igneous rock is after cooling and solidifying, right? These are called primary rocks, right? Because all of this process is starting from this particular section only, right? Before igneous rock, you will not find these particular rocks. After igneous rock, you will find these sedimentary rocks and metamorphic rocks. So through the sedimentation process that is starting with weathering and erosion, the sedimentary rocks are formed, right? If there is heat and pressure being applied on the igneous rock, then only metamorphic rocks are formed, right? So this is a very, very important aspect. It is very hard. It is because what is happening is basically lava is solidifying, right? So this is hard with no layers, in case of igneous rock. In case of sedimentary rock, what is happening here? So here, rocks when exposed to the denudation processes of weathering and erosion, say for example rainfall is happening, then there is transportation, deposition, right? After getting deposited, there is compaction, cementation, lithification that is happening, leading to the formation of sedimentary rocks. Lastly, metamorphic, heat and pressure, right? So these are some of the basic aspects. All right, now we are moving towards the different types of these igneous, sedimentary and metamorphic rocks also, right? In this case, one thing that you can remember is that metamorphism is having two factors, pressure and temperature, right? Pressure and temperature is seen in case of metamorphic rock, right? When we are talking about sediments, so this sedimentation can also happen through mechanical sedimentation, through chemical sedimentation, through organic sedimentation. So there will be different types. Let's see. So there are some basic idea. So igneous rocks example would be granite and obsidian. So granite is formed when lava is cooling down slowly. That is why intrusive igneous rocks, right? When lava is cooling down very quickly, it is extrusive igneous rocks. That is an example of obsidian. One of the examples would be obsidian. In case of sedimentary rocks, what is happening here? So here you will find sandstone, limestone, coal, etc. Now, coal is a very, very important sedimentary rock, right? Of course, it is because of the energy security reason, right? But it is a very important aspect that it is what kind of sedimentary rock? It is an organic sedimentary rock. Why? Because here biological matter has sedimented to form this particular rock, right? So coal is a sedimentary rock of organic characteristic. Then if it is called clastic when it is mechanical sedimentation is going on. When chemical sedimentation is going on, it is called chemical sedimentary rock, right? In case of metamorphic, there is, if there are having layers, right, it will have foliated metamorphic rock. If it is having no layers, it is non-foliated. Igneous rock anyway does not have layers. Sedimentary rocks, because of the process of deposition itself, will generally have layers in them, right? So it will have no layers. The sedimentary rocks will have layers, and generally speaking, metamorphic rocks have both, right? Foliated and exfoliated. Is that all right? So this is the different types of rocks that you'll find. There are some examples, right? Say for example, if we are talking about marble and slate, so they are metamorphic rocks. If you are talking about sandstone, limestone, so they are sedimentary rocks. If you are talking about granite and obsidian, they are igneous rocks. All right. So these are the different types of rocks that you'll find. Let's look at one of the questions here. Let's see how many of you are able to answer this correctly. This is from UPSC Prelims 2001, and it is talking about sedimentary rocks. Let's see how many of you are able to answer it correctly. All right, I'm hoping that you were able to answer this question. Now, we'll start with the next section with respect to geomorphology, and of course the last section, that is landforms, right? In case of landforms, what are some of the basic things? So we have seen when we are looking at the rock cycle that there was a process through which these rocks are getting transformed. In that, there are these geomorphic agents, right, that are having an effect on these particular landscapes, and they are transforming the landscape, and different landforms are created, right? The process starts with, of course, weathering, erosion, then these eroded sediments are getting transported and then deposited. So through this whole process, that weathering is then first of all breaking up the rocks, then erosion is happening, then this is getting transported through the, say for example, rainwater, and then it is getting submitted somewhere or deposited somewhere. So this whole process is going through, and it is leading to the evolution of different kinds of landforms, right? Now these are different processes that are involved. So there can be endogenic processes, exogenic processes, right? In that, we are going to look at the river, wind, sea waves, glaciers and groundwater as the important factors regarding the different landforms that they are creating. Now, basically what is happening is, first of all, every landform is being shaped, is being transformed, is having its own characteristic, right? And it is being transformed through the geomorphic agents, right? So they are transforming it one by one. They are going through a particular process. So initially what will happen is, we'll start with erosional landform and then we'll end with depositional landform. That is a basic thing that is happening. Of course, let's start with, if you look at the rivers, so you know the stages of the rivers, right? There is the early stage where the rivers are rising from the glaciers. So these kind of erosional landforms are found in this particular region. Here you will find rapids, waterfalls, right, in this particular region. As you move downwards, you will find the depositional landform, right. This is a very, very basic idea, right. Now, when we are looking at landforms made by rivers, these are called fluvial landforms, है ना? So, landforms made by running water, they will have different stages. So, in the youth stage of the river, you will have a very high elevation. Say for example, let's take the example of, this is the river Ganga and it is rising from the Himalayas, right. So, in the youth stage, it is coming from a very high elevation, right. It will have a lot of force, it will have a lot of speed of the water, will be quite high, right. So, it will do a lot of erosion, hence you will find which kind of landforms that are created in the huge stage. So, you will find rills and gullies, right. You will find rills and gullies, you will find V-shaped valleys, right. V-shaped valleys. Why? Because the force of the water is so high, right. Then you will find gorges and canyons, you will find rapids and waterfalls, right. So, this is from the youth stage of the river. So, these are some of the erosional landforms that are seen in the youth stage, right. Now, in that regard, let's look at some of the diagrams and some of the aspects regarding these erosional landforms made by rivers. So, there are different aspects. Say for example, if there is a small channel that is cutting through the rocks, so it will be rills. As it enlarges, it will form gullies, right. Slowly and slowly, it can even form rapids, right. It can form waterfalls in this particular time region. If there are stiff rocks on both the sides, you will find gorges here. Meanders and deltas are of course depositional landforms. We will take a look at them later. Now, in that regard, if you have a basic understanding of this particular section, so rills are very small streams that are cutting through. When they are enlarging, they are forming gullies. As these are enlarging even more and they are having straight mountains on both the sides, they are forming gorges. If there are step-like formations, they are canyons, and when it is forming a V-shaped valley, right, with the river flowing in the middle, that is an erosional landform mostly seen in the youth stage, right. Others one are of course rapids and waterfalls. This you will witness in Rishikesh, and waterfalls I am hoping that most of you would have heard about, right. Now, these are erosional landforms made by rivers generally in the youth stage. As we move towards the mature stage, right, this V shape will turn into U shape, right, and here slowly and slowly the transition is happening towards depositional landforms, right. Slowly and slowly depositional landforms will come about. Now, what are these depositional landforms that we are seeing here? So, here you will find alluvial fans here, right. So, almost like a fan like extension of alluvial deposits. Here meander formation starts, here floodplain starts appearing, right. Next, here you will see this, as this meander formation is happening, slowly and slowly there will be depositions on both the bends and it will create an oxbow lake, right. So, these abandoned meanders, due to this erosion that is happening in these particular regions, is forming oxbow lakes. These are depositional landforms, right. Next, as we move towards the old stage, here you will find all the major depositional landforms. Specifically, the most important one is the deltas, then the floodplains and the estuaries, right. So, I am hoping that you have a good understanding about deltas like Sundarbans and all, right. These are very, very important sections. In that regard, what you can remember is that deltas are being formed in India mostly in the eastern coast, and estuaries are found in the western coast, right, especially around the Narmada Tapi regions, right. So, these are some of the basic aspects from landforms or fluvial landforms. What are some of the things that you can remember here? So, here we have seen that the difference between a rill and a gully, and when we are seeing gorges and canyons, what is the difference? So, gorges have stiff, right, almost wall-like mountains on both the sides. Here you will find step-like mountains, right. V-shaped valley is in the youth stage. In the mature stage, you will find the U-shaped valley, right. In the mature stage, you will find the U-shaped valley, and as we move towards the old stage of the river, you will find the different landforms like depositional landforms like deltas, floodplains and estuaries. Alright, so this was with respect to fluvial landform. Next is the landforms made by glacier. Again, you will find some very important aspect. Now, glaciers are very important because they are having most of the fresh water on the surface of the earth, right? So here glaciers are formed how? So slowly and slowly, as snowfall is happening in the higher reaches, higher elevation regions, right? Slowly and slowly, the snowfall is compressing against each other, and so snow is compressing over one another, and because it is at such an elevation, right? So the temperature is very low. Temperature is low, hence you will find that it is having a very huge area of thick snow, right? Now, this is a very important aspect that you must remember, that whenever you are looking at glaciers, so it is mostly in, of course, colder regions, but the next important thing is these are moving masses of ice. So they are not still, they are moving masses of ice. So as they are moving about, they are causing friction, right? And because of this friction, different kinds of landforms are being created, right? So it's a very important thing that because of this friction that is being caused, right, because of their moving mass of ice, they are creating different kinds of landforms, right? Now, what are these landforms that you will see? So there are 3-4 major landforms with respect to glaciers, especially in the erosional stage, right? Now, in case of cirque, horns, arids and glacial valleys, right, we'll take a good look at these 3-4 important ones. What are cirques, what are horns, what are arids and what are glacial valleys? Shall we look at it? All right, let's see. The first one is the cirque, right? Now, as you can see here, this is a bowl-shaped depression. This is a bowl-shaped depression, right? Now, when we are looking at this particular area, you will see this is forming a cirque, right? It is a bowl-shaped depression, right? That is called a cirque and it is happening in generally kahan pe? So this is a very common type of erosional landform that is generally found at the head of the glacial valleys, right? That is generally found at the head of the glacial valleys that are in these kind of regions, right? So this is a cirque, right? Now, as the erosion is keep on happening, right? So as the headward erosion of the cirque walls is happening, so then these cirque walls become really pointed, very high, sharp, pointed side peaks, right? These are known as horns of these particular regions. So on the cirque walls, these high pointed peaks are known as horns, right? Then the separating boundary between two cirques are known as arids. And as we move towards glacial valleys, what are these glacial valleys all about? What is a glacial valley? What can you say, right? So in this case, these glacial valleys or glacial troughs that are formed due to the moving ice, these are U-shaped valleys formed due to the moving ice. These are known as glacial valleys, right? So overall, this whole region would be a glacial valley. On top of it, you will find the cirque, which is a bowl-shaped depression. On the cirque walls, when there is high pointed peaks, these are known as what kind of things? So they are horns, and when there are two cirques and there is a separating boundary, they are arids, right? So these are erosional landforms from glaciers, right? Now, there are also depositional landforms. In that, one of the most important is moraines. This you should remember, right? Because it is important with respect to Indian geography also and generally also. So what are moraines here? So these are basically soil, dirt and rocks. Soil, dirt and rocks that are left behind by moving glaciers, right? So these are materials that is left behind by the glacier, which are these? So soil, dirt and rocks. All right, this is a very important one. इसके अलावा there are other aspects like glacial till, right? So these are unassorted and coarse particles. All right, so these were the important landforms made by glaciers. We have seen the erosional ones, right? and then we had seen the depositional ones. In that, moraines are very, very important. Now, we will move towards the next one, that is the landforms made by groundwater. Now, as water is percolating down the, and we must know that there are, like, these are not the only depositional landforms. There are eskers, there are drumlins and all, but moraines is very, very important, right? In that regard, now let's move out to the groundwater. Now, in case of groundwater, what do you see? So, here water is percolating down the soil, and so there is, say for example, there is a river, right? And through this membrane, through this region of soil and rock, water is able to percolate down, and then here groundwater is running inside the earth, right? So, this downward movement of water and the horizontal flow of water inside the earth is creating some of the landforms. Now, which are some of the prominent ones that one can remember? So, there is, first of all, the downward movement of water and then the horizontal movement of water. This is creating a particular type of topography known as Karst topography, right? So, landforms produced by action of groundwater, right, is known as Karst topography. And what are the two processes that are involved here? So, one process is the solution, other is deposition, right? So, in both the cases there will be erosional as well as depositional landforms, but this is a very important aspect, that Karst topography is about the action of groundwater and the processes involved are solution and deposition. Now, there are different types of landforms that you will see here. Here you will find pools, sinkholes, and this can be this can come as a statement also. So, in which kind of landforms or in which type of geomorphic agent you will find pools, sinkholes, lapes, caves and pillars, right? So, these are found in case of Karst topography, right? Where is this Karst name coming from? So, it is coming from Adriatic Sea, Karst region of the Adriatic Sea. Here, what are some of the landforms that you will see? So, in case of erosional landforms, these are pools, swallow holes, right? Now, pools are what? So, these are the regions through which it is the groundwater is able to go down, right? Then there are swallow holes on the surface of the earth, right? Then there are sinkholes, solution sink and a collapse sink, uvalas, lapes, caves, natural bridges, right? These are erosional landforms. In case of depositional landforms, now this is a very interesting one, that if you are able to remember it through this visualization, you will be able to remember. So, there are important ones, just take a look at it. So, these are stalactites, right? These are hanging from ceilings. So, these are hanging from the ceilings, hence known as stalactites. Exactly ulta, right? When they are from the floors, they are rising from the floors. These are stalagmites. So, stalactites are hanging from the ceiling, stalagmites are rising from the floor. When these two stalactites and stalagmites are meeting, they are forming pillars, right? So, both the actions are happening here. So, due to the fusion of stalactites and stalagmites, you will find pillars. Then there are drapes and dripstones. So, these are all depositional landforms, right? Deposition is happening. Here, all of these are erosional landforms. It is eroding and forming these landforms, all right? So, there are both erosional as well as depositional landforms. You can expect, okay, swallow hole, sinkhole, solution sink, collapse sink are what kind of landforms, or are what kind of erosional landform or a depositional landform, right, are coming under Karst topography, or say for example sea waves, right? So, these are some of the different ways through which UPSC can ask you questions. Stalactites and stalagmites are very, very important. You can expect sometimes you can like expect these kind of terms to be used in some part of the question or even the options, all right. Next one is the landforms made by sea waves. Now, in case of sea waves, very easy to remember, right? Now, because what is happening is due to the movement of the sea that is falling on this particular, say for example, part of the earth, right? So, due to the movement of the seas, due to the movement of the breaking of the sea waves, right? Again and again, sea waves are breaking on this particular region, right? Now, what will happen here? After some time, there will be some lines of weakness, almost like a fracture that will happen, right? So, in these lines of fracture, if the sea wave movement is happening continuously, Then you will find the next one, that is a cave. Slowly and slowly it will erode that particular area, right, and it will form a cave. As this cave is properly eroded and the walls are gone, then it will form an arch. So arch is just nothing but eroded sea cave, right, whose walls have been eroded fully, right. So it will form an arch. Now as this arch becomes bigger and bigger, right, after a point the arch will collapse, right. After a point the arch top will collapse and it will form a stack, right. Now after this stack is getting eroded again and again, it will form a stump. So you are finding this whole transition from a line of weakness to a cave, to an arch, then a stump, then a stack, then a stump. All of these are what? These are erosional landforms, right? These are erosional landforms created by sea waves only. There are others also, right? So there are terraces also, others also, but this is very, very important, right? So from a line of weakness, then there is a depression, right? Then as this depression is losing its wall, it is forming an arch. As this arch is again, the roof of the arch is collapsing, it will form a stack and then finally a stump, right? So this is a very important aspect. Next is in case of, say for example, so these are all erosional landforms. In case of depositional landforms made by sea waves, so again this is a very easy one, beaches, है ना? So here all the different fine particles, pebbles, right, rocks, right, these are coming, seashells are coming and getting deposited in a particular area, hence these are forming beaches. Then there is dunes, right. So what you are going to see in case of desert region, you will also find in this particular area. So due to the action of the wind, you will find dunes here. So these are ridges or series of ridges, है ना, that are around this beach region, right. So you will find dunes, right. Now this dune is very important to remember, because generally we are talking about here the landforms that are created by sea waves, but dunes are not created by sea waves. It is created by the action of the air, right. That is why you must remember that these are dunes, and these dunes are created by the action of air, even though we are covering it under depositional landform made by kisse sea waves. All right. Other ones would be bars, spits and barrier bars, right. But this is a very important section. All right. So these are depositional landforms, and beaches, dunes, bars, spits and barrier bars, right. All right. So this was with respect to depositional landforms, and we have looked at the major landforms that have been created by, we started with rivers, then glaciers, then we had looked at groundwater, and we have completed our sea waves. The last one, that is the landform made by winds, we are going to see. These are also known as Aeolian landforms, right. Now in case of landform made by winds, which are the conditions under which you will find these kind of landforms? So this will be seen in regions where there is very dry climate, very sparse vegetation, very little rainfall, right, where the soil is very loose, very semi-arid and arid conditions. In that regard, if there is strong winds that are witnessed, these will create these landforms that are known as Aeolian landforms, generally speaking, right. Again, it will start with weathering and erosion, right. Now in that regard, what are some of the important landforms? So in case of erosional landforms made by winds, one of the most distinctive is the mushroom rocks, where the base is being eroded, right, where the base is being eroded and the top is a bit wider, giving it a mushroom shape. It is an erosional landform made by wind, right. The next one would be caves, where very similar to what was happening in case of sea waves, because of constant action of the wind, it is slowly and slowly taking out the sediments, right, and then as a deflation is forming on the rock, it is creating a cave like structure, right. Now the next important one is pediments and playas, right. What are these pediments and playas? Of course, they both are erosional landforms made by wind, generally in the desert regions. All right. So these are erosional landforms made by winds. Next one would be the depositional landforms. In that, one of the most important is sand dunes. Of course, there are different types of sand dunes. Say for example, crescent shape, longitudinal, transverse, parabolic. What you can do is, generally speaking, if there is a going to be a question, so it will try to ask you in comparison to each other. So crescent and parabolic you can have a basic understanding how they are different and how similar they are, and then longitudinal and transverse, there you can have a basic understanding, right? Now, in that regard, let's look at the first one, that is the crescent shaped or barchans, right? Now, here what is happening is wind is coming from this direction, right? And the top of the crescent, and the top of the crescent, this particular section is facing the wind direction, right? And the legs are in the opposite direction, right? So it is forming a crescent shape with the top towards the wind direction, right? Here there is no vegetation, vegetation is absent, the places are like Sahara Desert, Thar Desert, core areas of the Sahara and Thar Desert. But in cases where the vegetation is present, here the top is, right, is the top of the crescent is in the opposite direction, right? Is in the opposite direction, right? So in this case it was towards the wind direction, it is now opposite the wind direction, because these vegetations are forming like an anchor, right? And this the legs of the crescent are in this particular direction. So exactly, if you see, if from between the two of them, barchans and parabolic dunes are exactly mirror opposites of each other, because one of the reasons is that in case of parabolic dunes the vegetation is present, in case of barchans vegetation is not present, right? Both are similarly shaped, right? But the wind direction is causing the head of the crescent to fall in exactly opposite directions. Is that all right? Now, where would you find these parabolic dunes? So this is generally seen in semi-arid regions, right? This was in case of barchans, it is in properly areas where there is no vegetation, Sahara and Thar deserts, in the core regions of Sahara and Thar desert. But in case of parabolic dunes, these are in semi-arid regions, right? There is aridity, but in semi-arid regions, all right? Now, in case of longitudinal and transverse dunes, what is happening here? So here, these are elongated dunes, right? But they are lying parallel to the wind direction, right? In this case, in case of transverse dunes, they are again similarly shaped dunes, but perpendicular to the wind direction, right? So wind is coming from this side, and you will find a this kind of dune formation here, right? In case of longitudinal dunes, the dunes are in the same direction as the direction of the wind, right? So this is perpendicular direction, this is parallel direction, hence longitudinal and transverse dunes, right? So this covers all the major sections with respect to our geomorphology, right? Just take a look at this question and try and answer it, and let's see how many of you are able to correctly answer this particular section. All right. So now that we have covered our geomorphology section, we are going to start with climatology, right? Now, in case of climatology, what are some of the basic things? So if you look at the previous year questions from the last 10 to 15 years, you will see a particular pattern in their questioning. Of course, the standard of questions have risen quite a bit, but if you see where are the areas that UPSC is focusing on, so it is focusing on the atmosphere and its properties with respect to, say, for example, here it is asking about temperature, right? Then it is asking about solar radiation as well as temperature. Next question is regarding the layers of the atmosphere. Next, you will see some very basic questions with respect to water vapor and monsoon type climate, right? And a very important topic for this particular year, because this is a super El Nino year, right? So El Nino and La Nina has also been asked in 2011, right? So these are some of the major topics that we are going to focus on. Let's look at some basic aspects with respect to atmosphere, right? So whenever we are talking about the atmosphere, it is made up of three things, right? Or it is a mixture of three major aspects: gases, water vapor and dust particles, right? And it is held together to the earth by the effect of gravity, right? These are very basic aspects. I'm hoping that you are 100% clear about this, right? Now, what you will see is as we move up, right? So as we move up in the atmosphere, the proportion of gases change. So even though we have a basic understanding about the composition of the atmosphere, so that nitrogen is this many percent, oxygen is this many percent, but these compositions, these proportions change as we go higher up, right? Now, we had seen that gases, water vapor and dust particles make up the atmosphere, right? A basic aspect. Now, gases are what type of matter? So it is lacking both definite shape and volume. But in case of dust particles, these are solid matter, right? Water vapor is the gaseous phase of water, right? So even these kind of questions may be asked as a simple statement based question, right? That all the different compositions or the constituents of the atmosphere have similar characteristic. That is not the case. Gases are of different characteristics than dust particles, and they are different from water vapor, and they have their own properties also, right? Now, with respect to composition, the next important aspect that you can remember is that oxygen is negligible beyond 120 kilometers, right? And similarly, carbon dioxide and water vapor is found only up till 90 kilometers. So these two become really important for you, that oxygen is very little beyond 120 kilometers and carbon dioxide and water vapor is only up till 90 kilometers. This is a very, very important aspect. All right. So these are some of the important aspects relating to the composition, the constituents of atmosphere. Now we are moving towards a very, very important section, that is the layers of the atmosphere. Now, what are some of the basic things that we know about layers? So there are troposphere, stratosphere, mesosphere, thermosphere and exosphere, right? And in between these layers you will find ionosphere also, right? So between these layers of thermosphere and mesosphere you will find a sixth layer, that is ionosphere. That is not a continuous layer, right? But we'll see what are its important characteristics, right? So in these layers, what are the things that you may be asked? So in case of troposphere, it is the layer closest to the earth's surface, right? If this is the surface of the earth, you will find the first layer that you will witness or where we are living is the troposphere, right? Its average height is between 8 to 18 kilometers, right? Now a question can arise is, why is it between 8 to 18 kilometers? What is the most important aspect that you can remember? Where would it be 8 kilometers? Where would it be 18 kilometers? This is very, very important, right? Now we know that the shape of the earth is not a perfect sphere. It is an oblate sphere. In that case, what will happen? There is a flattening of the top and bulging in the middle section, right? If there is a bulge, then the radius that you will find at the equator will be longer and the radius that you will find going towards the poles will be shorter. Hence, now what will happen? We know that atmosphere is held together by gravity. Now, if poles are feeling more gravity, the poles are feeling more gravitational pull. Hence, the kilometer that you will find at the poles will be lesser, that is 8 kilometers. And equator, because of the bulge, because of the equatorial radius being longer, right? What will happen? In comparison to the polar radius, it is having lesser gravitational pull in this particular area. Hence, it is going up till 18 kilometers, right? So, this is a very, very important aspect, that 8 to 18 kilometers. Why is it so? Because of the difference between polar radius and equatorial radius, right? This is you are seeing with respect to troposphere mostly, but it will have an effect. You can be asked this question with respect to troposphere, that why is it that its range fluctuates from 8 to 18 kilometers. Next important aspect is that where would you find all the weather related changes? Not most, not majority, all the weather related changes. It is in the troposphere that you will find all weather related changes taking place, right? Now, as we move up, say for example, if you are moving from Delhi, right, where we are today, and you are moving towards Mussoorie, so what you will find is that temperatures go down, right? Now, this temperature going down is a characteristic that is not seen uniformly across all the layers. So, when we are coming to that particular portion, we will look at it, that where is it increasing, where is it decreasing, and why is it increasing and decreasing. All right. So, these are some of the basic aspects with respect to troposphere. The boundary between the troposphere and stratosphere is known as what? What is this boundary known as? It is known as tropopause. So, this boundary that you are seeing here is known as tropopause. Okay? Is that all right? Is it clear? No issues here? 8 to 18 kilometers because of the difference between polar radius and equatorial radius. All right. Now we are moving towards the stratosphere, right? Now, first of all, this is the layer that is having the ozone layer. So it becomes really important, right? And that this ozone layer is also the reason why the temperatures would rise as we move up, right? So here temperatures dip as we move up, right, in the troposphere. But in case of stratosphere, temperatures rise as we move up, right? The reason being the ozone layer that is absorbing the incoming solar radiation, right? So because the ozone layer is absorbing the incoming solar radiation, the temperature rises with altitude, right? It is going up to 50 kilometers, right? So the most important thing that you can remember with respect to stratosphere is that there you will find the ozone layer that is absorbing the sunlight, hence it is increasing, the temperature is increasing as we move up. Now we move towards, now this is again the boundary line, this is called this was tropopause, this is stratopause, right? So this is between stratosphere and mesosphere. This is a, which boundary line is it? It is stratopause. Now as we move up towards the mesosphere, what you will find here, so this is between 50 to 80 kilometers, right? In this particular range, meteors burn up, right? Now this becomes very important, the differentiation between meteoroid, meteors and meteorite. I'm hoping that you have a basic understanding that when would you call a particular body meteor, when would you call it a meteorite, when would you call it a meteorite. If not, these are very basic things from like basic NCERT geography. You must have some basic understanding regarding these things, right? So in mesosphere, these meteors are going to burn up, right? This is the most important aspect with respect to, again, mesosphere. Here again the same phenomena is seen as was the case with troposphere. Here again, as we move up, the temperatures will go down. So temperatures are decreasing with increasing altitude. That was not the case in case of stratosphere, where there was the ozone layer that was absorbing the sun's rays. Next, as we move up, there is the thermosphere, right? Now this is a very big layer from 80 to 700 kilometers, right? This is a huge area, right? Now in this case, what is happening is, now it is very, very close to our space, right? It has not yet reached space, because after this there is also an exosphere, but now it is very close to the space. Now it will receive a lot of sunlight. That is why here now the temperature will keep on increasing, right? So it's a very, very important aspect that first it was decreasing with altitude, then it was increasing with altitude. Now in the third one, in the case of mesosphere, again it was decreasing with altitude. Now as we move towards thermosphere and exosphere, it will keep on increasing, and it can go as high as kitna? So 2000 degree Celsius, right? So it's a very, very important aspect. In this particular area, you will find the International Space Station around 400 kilometers ke aspas, right? In this particular area, you will find auroras, right? Now, do you have a basic understanding regarding auroras? What are they? What are the important aspect? So we'll see if you have a basic idea about it or not. You know, they are also known as northern lights, right? So we'll see what are these auroras all about. So in this thermosphere, the temperature is increasing with altitude. It can go up till 1500 degrees Celsius in case of thermosphere, and in exosphere it can go as high as 2000 degrees Celsius. And here auroras are seen. Here you will see spacecrafts are seen. Here you will see International Space Station in this particular area, right, around 400 kilometers altitude. Next, and among the continuous layers, the last one, that is, now you will find the exosphere. Now before we are going towards the exosphere, we had talked about a layer that is partial, right? So partially seen in case of which two layers? So thermosphere and mesosphere, there are some partial layers that are known as ionosphere. So these are regions where you will find that because of the intense solar radiation, it is able to knock electrons loose, right, from its parent atom. So basically here you will find ions. So these are loose electrons, right, that are known as ions, hence the name ionosphere. So these are some pockets that you will see in between the thermosphere and mesosphere, right? This is a very important layer. Why? Because radio waves are transmitted here, right? So it becomes important in that regard. So these would be some pockets of the ionosphere. Now as we move towards the last layer, that is the exosphere, what are some of the basic things? First of all, it is the outermost layer located above 700 kilometers, and it is slowly merging with space, right? So the atmosphere there will be very thin, right? Very little amount of gases are there, right? It is very low density. it is merging with space, and satellites are some of the major bodies that are found here, right? So artificial satellites are found in this particular area, right? It is also allowing the particles to escape the gravity, the gravitational pull of the earth, right? So these are some of the basic idea, or some of the basic aspects regarding the layers of the atmosphere. Now, we have seen this temperature variation, so let's look at a particular diagram that will tell us about it. Before that, if you remember, in this particular layer there was auroras. So let's look at basically what are these auroras all about, and then we'll look at this temperature inversion thing, right? So if you look at this auroras, it is a very important aspect. So these are luminous displays, right? In generally polar regions, especially if you look at go to the Scandinavian parts of the Europe, right? So there you will find these northern lights or auroras where people flock, and it's a huge tourist destination, and people flock to look at these lights, right? What are these? So they are basically caused by the collision of charged particles from the sun, right, through the solar wind, that are coming to the through the solar wind with atmospheric gases, right? And it is happening along the Earth's magnetic lines. You remember we had talked about magnetic lines when we are looking at the interior of the Earth, which is the layer inside the Earth that is responsible for these magnetic lines. So can anyone tell me in the comment section, right? So there we are seeing a collision of charged particles from the sun with atmospheric gases along the Earth's magnetic lines, causing these luminous displays that are generally seen in the polar regions, right? So these are auroras. All right, now we will move towards the next one, that which is, or how do we see the temperature differences in this particular, the different layers of the atmosphere. So we know that as we move up the troposphere, the temperature is decreasing, right? So in troposphere, temperature is decreasing. Then in the stratosphere, because of the presence of ozone layer, the temperature is increasing with altitude, right? Then in the mesosphere, again it is decreasing, generally, it is decreasing, and this is the mesosphere. The mesosphere is the coldest layer of the atmosphere, right? Now this becomes a question, right? So this you can remember that this is the coldest layer of the atmosphere. Next, as we move up towards the thermosphere and exosphere, so due to a intense heating from the sun's rays, now it will keep on increasing, and it can go as high as 2000 degrees Celsius in case of which one? It is the exosphere. All right. So decreasing, increasing, decreasing, increasing, and it is keep on increasing. All right. So this is with respect to the temperature differences, right? Now, what is happening when the sun's rays are hitting the atmosphere, right? So there you will see, is this clear? Is this part clear for all of you? No issue still here? All right. All right. Is this clear? Right. Now that we have looked at some of the basic aspects with regard to the different layers of the atmosphere and important aspects regarding them, now we will move towards the next, that is solar radiation. Now, what is solar radiation? Solar radiation is nothing but the source of all energy on Earth, right? So it's a very, very important aspect. These are electromagnetic radiations that is emitted by the sun, right? And this is of what character? It is short wave radiation, right? So it is the source of all energy on Earth. But how is it different from insolation? So the whole of it is known as solar radiation. All the energy that is being released by the sun, right? It is through the solar radiation. But when we are talking about insolation, we are talking about specifically the amount of solar radiation received by a specific area on Earth, right? This specific area is very important. That will be its differentiation with respect to insolation and solar radiation, right? So when we are talking about the whole of it, that the sun is emitting, that is solar radiation. When we are specifically talking about the amount of solar radiation received by a particular area, that is insolation, right? So this is very, very important. Now, how is insolation and temperature correlated? So if you look at it, insolation is the heat energy received by the Earth, right? temperature is the measurement, right? So it becomes, what is the correlation? This is the cause, right? This is the solar radiation that is being received by the earth, and its effect would be the increase and decrease of temperatures, right? So this is the cause and this is the effect. This is very, very important. Of course, the other aspect is it is measured in calories. Here temperature is measured in Celsius and Fahrenheit. That is, I am hoping that most of you would know. But the cause and effect relationship between insolation and temperature is very, very important, right? Now, the next aspect is, what is the heat budget of the earth and how is it calculated, right? So if you look at the heat budget, it is the balance between incoming solar radiation, right, that is insolation, and the outgoing terrestrial radiation, right, that is being emitted by the earth's surface. Now, what is this terrestrial radiation now, right? Now, this is a particular portion that has been asked before in your UPSC exams in the last few years also, and we will properly look at it through proper flowcharts and diagrams so that you are able to 100% remember it when if it is asked in the exams again, right? So we have basic understanding of insolation. Now we are moving towards how earth is heated up, right? What is happening when insolation is being received by the earth? What are the different components regarding this particular phenomena? And then how is it that atmosphere is getting heated up? All right. So let's look at the first aspect, that when this solar radiation is being received, right, what is happening here? So this will be the insolation that is being received by this particular area. So let's assume that this is all the solar insolation that is being received. This is 100%, out of which around 7% is scattered in space, right? So here only you will see that 7% is already scattered in space. Next, now as it is being received by the earth's surface, 47% is absorbed by land and sea. This is a very, very important aspect, that the most amount of solar radiation is being received, is being absorbed by land and sea. Only 23% is being absorbed by the atmosphere, right? This is a very crucial aspect that you can be directly asked in the exams, right? So out of the 100%, 47% is absorbed by land and sea and 23% is absorbed by the atmosphere. Now, there is also another thing called reflection. Have you heard about albedo effect, right? So the solar radiation that is being received by the earth is getting reflected back also, right? Which are the things that are reflecting it? So it is reflected by clouds around 17% and as well as land, that is 6%. Taken together, there is 23% that is reflected back also, right? So this is reflection. So incoming solar radiation being absorbed by land and sea 47%, absorbed by atmosphere 23%, and reflection by clouds and land 23%. Taken together, they are almost accounting for the 100% that is of the solar insolation that is being received, right? If you want to have a basic idea, so this is a flow chart. So this is the insolation, the incoming solar radiation, the short wave radiation that is being received by the earth. It is getting reflected back, right? So here you will see by clouds and by the earth's surface, right? This is known as albedo effect, right? It is being absorbed by atmosphere and as well as the land and sea, and after it is being absorbed by the land and after it is being absorbed by the atmosphere, it is causing terrestrial radiation, right? Now this terrestrial radiation is the outgoing radiation, right? Now insolation was short wave radiation, right? Now when it is getting reflected back, if you see, this is short wave radiation, but when it is getting reflected back, it is long wave radiation, right? So its wavelength would be longer, right? So this is one crucial difference between insolation and terrestrial radiation. This is short wave, this is long wave radiation. Okay? All right. Next important aspect is, now after terrestrial radiation is happening, what is happening to the atmosphere? How is atmosphere getting heated up, right? So we have understood okay, how is terrestrial radiation happening? Now we are moving towards how the after the earth has been heated up, how is atmosphere getting heated, right? Now this is a very, very crucial point to remember, that atmosphere is heated from below, right? This is heated from below and not directly by the solar radiation that is being received. So here the heat is coming from below, from terrestrial radiation, right? The long wave radiation, that is the major cause of heating of the atmosphere, right? It is not being directly heated by the sun, but by the terrestrial radiation. So the insolation that is being received by the sun is heating the earth's surface, and that is heating the atmosphere. All right. So this becomes a very important flowchart for you to remember. If you look at the proper process that is going on here, so this solar radiation that is being received by this particular area on earth is heating it up, right? Here terrestrial radiation is happening. Now terrestrial radiation is doing three important things, right? This is, first of all, it is transferring the heat above it, and air is getting heated up. As the air is getting heated up, it will do what? It will rise up. That is, so first of all, the heating of the air above the land is the conduction. Next, as the air rises, that is called convection. You remember we have talked about convection, convectional current in case of interior of the earth also just a few minutes back, right? So as the air is rising up, that is called convection, and as it rises up, what will happen, right? It will start to cool down, right? So it will move from high pressure to low pressure. So the wind is moving horizontally from high to low pressure, that is called advection. This is the mechanism that is associated with the heating of the atmosphere, right? So the solar radiation is heating the earth, right? This terrestrial radiation is transferring the heat to the air above it. That is how air is getting heated up. As the air gets heated up, it is rising up. So convection is happening, and then advection is happening from where in the upper atmosphere, where you will see that the wind is moving horizontally from high pressure to low pressure. This is a very, very important aspect for you to understand. If it is clear, most things in climatology will be very easy for you to remember, right? First of all, the temperature is the insolation that is being received is causing terrestrial radiation, and this terrestrial radiation is then causing the heating of the atmosphere. All right, is this absolutely clear for all of you? No issues. So insolation is causing terrestrial radiation, that is causing conduction, that is causing convection, that is causing advection. All right, right? Now this conduction is happening in the lower atmosphere, right? Convection is happening and the warm air is rising up, that is vertical transfer of heat is happening, and then finally in advection the wind is moving horizontally from high pressure to low pressure. I'm hoping by now it is clear for all of you, right? This is a very, very important section with respect to our climatology. This is the basic physical part about the insolation, the heat that is being received by the earth, the terrestrial radiation that is happening, and the heating and cooling of the atmosphere. Now we will move towards elements and factors of climate, right? Now there are multiple elements to it, there are multiple factors to it, right? What are some of the important elements? So it is temperature, precipitation, pressure, wind, humidity, evaporation, cloud cover, right? We are going to focus on some important areas where we think that is most important for you to revise. There are also factors. So with respect to every single one of these elements, there are factors that are involved. So with respect to temperature, there will be factors related to latitude, altitude, distance from the sea, oceanic currents, relief orientation, right? Direction of the planetary wind and season. So all of these are conditioned on these particular factors, right? So there are elements and there are factors of climate. We will start with, of course, temperature, and let's see what are some of the basic things regarding this particular aspect. What is temperature? We have already seen it is the measurement of hotness and coldness, right? So basically the amount of solar radiation or the amount of insolation that is received and absorbed by the earth is creating what? Is creating heat that is measured in terms of temperature, right? And this we are seeing if you look at the global distribution of temperature. So we see, or we have read about heat zones of the earth. So wherever there would be direct rays of the sun, right, between the tropics, they would be called the torrid zone, right, where you will find very high temperatures, right? As we move up, there is temperate zone between the Tropic of Cancer and Arctic Circle and Tropic of Capricorn and Antarctic Circle. And as we move towards the poles, where the slanted rays of the sun are reaching, where direct rays of the sun are not reaching, there you will find frigid temperatures, right? Frigid zone or zone of low temperatures, right? All right. So I'm hoping that heat zones are clear to you. This is a very basic aspect, right? I'm hoping that you have a basic understanding about all these imaginary lines that are running parallel to the equator, right? Now we are moving towards a very important section now, that is the relationship between temperature and pressure. And we are of course talking about the troposphere right now, right? So what you can remember is very, very importantly, as temperature increases, pressure decreases. As temperature decreases, pressure increases, right? This is a general phenomena that you will see in the lower atmosphere, right? Here, basically what is happening is, as you are putting pressure, right? As you are putting pressure, right? So this is basically, what is air pressure? This is the pressure created by the weight of the air. So it is trying to escape in all directions. Very similar to us as students, right? So we want that as soon as possible, we are going from high pressure to low pressure area. So here there will be high pressure. So it is trying to escape wherever it is finding lower pressure, right? In comparison to this pressure that is being put here, right? So it is exerted in all directions and it is moving towards low pressure. Now the most important thing is that temperature and pressure are inversely proportional to each other, right? For our climatology section, this you can remember because troposphere, it is in the troposphere that all the weather related changes are happening. So in this particular area, you can directly correlate this, right? Now, this particular section is very important because here you will try and understand what is the mechanism that is happening here, right? So as land is getting heated up, so terrestrial radiation, right? It is transferring its heat, right? So conduction is happening, and as conduction is happening, the air is rising up and expanding, right? So convection is happening. And here in this particular region, what will happen? So because the air is rising up from this particular area, it is low pressure area. The air is moving towards this particular area, it is high pressure area. Now we know that air moves from high to low pressure, right? So what will happen? There is a horizontal movement. So this will be the wind, and it is moving from high pressure to low pressure region, right? As it is moving this particular area. Now because altitude is quite a bit high, right? So it is also getting cooled down, and cooler air sinks, right? And as the sinking air is descending, right, then again what will happen in this particular area? What is the basic phenomena that is happening? So this area will now experience high pressure. Again this wind will blow from this to this area. This is also the reason for land breeze and sea breeze, right? So during the daytime, what is happening here? So land is getting heated up quickly, right? So air is expanding, going to this particular area, and sea takes a while to get heated up, right? So here you will find that there are cooler temperatures here. So temperature is less, so pressure will be more, right? So as you will see that temperature is less and pressure is more, so there will be sea breeze, right? And when it is night time, now the sea is much warmer than land, right? So it will reverse, and then there will be what will happening? So this is the cooler region during the daytime. This will be the cooler region during the night time. So the direction of the wind will change, and then you will experience the land breeze, right? Sea breeze and land breeze is a very common concept, but it is also giving you a good idea about how these things are interacting with each other, how temperature and pressure are interacting with each other. All right, this is a very, very crucial aspect. If you are clear about this thing, that conduction, convection, right, advection, right, and then what is happening during the daytime? The specific heat of water is doing what? So if I'm hoping that you have a basic understanding about specific heat. So sea is still cooler because of the whole night's nighttime temperature, right? Land is getting heated up quickly, right? So there will be sea breeze during the daytime and there will be land breeze during the night time. Why? Because during the night time, the high pressure condition will be seen in this particular area. Is this clear? All right. Now, what are some of the lines that will give the same temperature known as? So these are isotherms, right? These are lines joining the places with same temperature, right? These are very basic idea. Isobars and isotherms. Isotherms are related to the places that are having the same temperature and they are connected to the same line. Isobars would be same pressure connected to the same line. All right. Next important aspect is thermal inversion, right? So normally speaking, what is happening? So normally the temperatures will do what? So we know that there is a inverse relationship, है ना? So as height is increasing, temperature decreases. But in some cases, in cases of long nights, clear sky, dry air, what will happen? The temperature will increase with height, right? So these are the exceptional situations when you will not feel that the normal course is happening, right? You are feeling that in case of long nights, clear skies and dry air, what is happening here? Temperature is actually increasing with height. Now, there are different aspects related to it, and there are different reasons for it, but I'm hoping that this temperature inversion portion is clear to you, that here this is the temperature is increasing with height rather than decreasing, right? So in a way, temperature inversion is a very peculiar concept, right? In case of whatever we have studied till now, that in the troposphere, as we go up, the temperature should decrease, right? But here, the temperature is increasing with height, right? Of course, they're happening generally in very extraordinary circumstances. Say, for example, these are some of the situations. We will look at one of them and we'll try and understand what is happening here. So, in case of long nights, especially generally during the winters, what is happening is, so during the night, the earth is losing heat. So longer the night, more heat is lost, right? And slowly, the ground is getting colder, right? Now, as the ground is getting colder, the air just above that ground is also very cold, right? So temperature has dropped in that particular case. But that is not the case that is of the air that is at the higher altitudes, right? So higher altitude air is still not as cold as the lower altitude air. So as you are moving up, the temperature rather than decreasing is actually increasing. That is thermal inversion. All right. That is a similar phenomena that is happening in other cases also. All right. So what we have seen, or what are some of the basic aspects that we have seen? So insolation is being received by the Earth's surface. It is heating up the Earth's surface, causing terrestrial radiation, due to which air is becoming warm. So conduction is happening. It is rising up. So convection is happening, right? And then this low pressure that is being created here, the cold air is replacing the warm air, right? So there is advection that is happening, specifically with respect to the movement of winds. So horizontal movement of air is happening, and that is creating the winds, right? So this is some of the very, very important topics that you are going to face in this particular area, right? Now, the next phenomena or the next important aspect or topic from this particular section is the cyclones, right? Is this clear for all of you? Is this whole phenomena clear for all of you, right? This is a very, very important section, right? Just take a good look at it. If there is any doubt, ask, and then we can move forward. All right. All right. Now, let's move towards the next important topic, that is the cyclones, right? Now, what is a cyclone? What is this whole area all about? So here, this is an area of intense low pressure at the center that is being surrounded by high pressure winds, right? So here, what is happening is that this low pressure area at the center is being surrounded by high pressure regions, and winds from all sides are moving towards the eye of the cyclone or towards the center of the cyclone, right? Now, in this regard, what is the direction and how is it different in different hemispheres of the earth, right? So in the case of northern hemisphere, the Coriolis force is moving towards the right, hence the direction would be here, it is in the anti-clockwise direction. If you can see this particular diagram, you can properly understand that this is anti-clockwise direction. In the southern hemisphere, because of the Coriolis force moving towards the left, it is clockwise direction. So this is very, very important Coriolis force. I'm hoping that you would have a basic understanding about, right? So cyclones are having particular directions in different hemispheres, right? They are also known by different names. This has been asked before. So in case of Indian Ocean region, it is known by a particular term, right? As you move towards the Pacific, right? As you move towards the Atlantic, Australia, right? So it is known by different names in different regions. Is this clear, right? You must have a basic understanding. So it is known by cyclones in Indian and Southern Oceans, right? It is known by typhoons in case of Pacific. It is known by hurricanes in case of Atlantic, right? Now, there also around the area of USA and Mexico, it is known as tornadoes also. and in Australia it is known as Willy Willy, right? Now there are different types of cyclones. There are tropical cyclones, there are temperate cyclones, there are polar cyclones. We are going to focus on these two, that what are some of the important differences between tropical and temperate cyclones, right? Now in this regard, what are tropical cyclones and how are they different from temperate cyclones? We'll properly make a table out of it, and so that you are able to revise it better, right? So in case of tropical cyclones, cyclones that form over the warm tropical oceans, basically around the tropics, right? 5 to 30° north and south latitudes. These are known as tropical cyclones. It is, the naming is because of the region that they are forming, right? In case of temperate, of course, it will be in the mid latitudes, right? So here what is happening is, so cyclones that are forming in the mid latitude, right? And it is between the fronts, warm and cold fronts, right? So here it is a very, very important aspect, that where are they forming and the term that are associated with these particular cyclones. Now, which are these latitudes? So in case of tropical cyclone, it is 5° to 30° north and south. In case of temperate cyclone, it is 30 to 60° north and south, right? That is why they are known as mid latitudes, right? In case of the formation area, it is generally over the warm ocean in case of tropical, and in case of temperate cyclones, it is in the mid latitude regions, right? Now this mid latitude region can be land as well as sea. In case of energy source, so they are receiving energy from the what? From the warm ocean that you are seeing in the tropical region. In case of temperate cyclone, it is due to the temperature contrast. Hence, the air mass is warm and cold air mass. That is the reason that the temperature contrast is seen in case of temperate and not tropical, right? So tropical cyclones are receiving from the warm oceans, right? Heat from the warm oceans. Temperate cyclones are happening due to temperature contrast, warm and cold air mass, right? Frontal formation is happening, in which case it is happening in the case of temperate cyclones and not in tropical cyclones. All right. Next important aspect, what is the structure? How would you find, if you are looking at a particular cyclone, how would you say that it is a tropical cyclone or a temperate cyclone? So in case of tropical cyclones, they are generally symmetrical in structure, right? There will be a defined eye here, right? Generally smaller in size, but with a defined structure. That is not the case in case of temperate cyclones. They are asymmetrical, right? But they are larger in size. So size is larger in case of temperate, but the symmetry is seen in case of tropical, right? Duration, again, because it is very, very intense. So here it only lasts few days, right? Here it can last up to several days and even weeks. All right. Rainfall, again, tropical cyclones are intense in character, right? So they will bring a lot of rain in a particular area, right? And for a few days, but a lot of rain. So intense but localized. But in case of temperate cyclones, it is widespread. In a huge area, they are going to bring rainfall, right? So this is a basic idea about these particular aspects, right? These are very important aspects. So we are looking at latitude, formation area, energy source, and frontal formation. Next is structure, size, duration, and rainfall. Most of the questions that you might be asked is coming from these 7-8 parts only. If you are able to have a good revision out of these two things, I think you are going to answer most of the questions from this cyclone section. All right. Next is the clouds, right? Now, as evaporation is happening, right? So water vapor is also rising up, and when this water vapor is combining with dust particles, it is forming a condensation nuclei. So water vapor, as it is rising up and combining with these dust particles, it is forming these condensation nuclei, right? And as these condensation nuclei slowly are gathering together, right? They are gathering together, they are getting accumulated, they will form clouds, right? There are some major types of clouds that you must have a basic understanding about. These are cirrus, cumulus, stratus, and nimbus, right? And then there are multiple combinations of them, right? But at least these 4 major types you must have a basic understanding about. All right, shall we move ahead? Is this clear up till now? Is the cyclone section clear for all of you? Is there any doubt regarding any of these particular aspects? All right. Now let's move towards the different types of clouds. We are only focusing on major 4 types, right, that are major types of clouds, right? So in this regard, we'll first look at the cirrus clouds, right? Where would you see cirrus clouds? So this is the cirrus clouds, right? In this regard, what is it? So it is formed at high altitudes. So it is a high altitude cloud. How high? So 8,000 to 12,000 meters high, right? It is very thin. It is detached cloud, right? It is having very feather-like appearance. It is white in color. So cirrus clouds have some very important characteristics, that it is formed at high altitudes, it is thin and detached, it is having feather-like appearance, and it is white in color, right? This is cirrus clouds. Now, as we move towards the cumulus clouds, right? Now, see this cotton wool kind of shape, right? Now, these are looking like cotton wool. That in itself becomes very important. Next is, these cumulus clouds are formed around 4,000 to 7,000 meters in altitude, right? So they are lower than the cirrus clouds, right? So 4,000 to 7,000 meters would be their area, right? And they are scattered in character, right? They are scattered in character. So we have seen two, cirrus and cumulus. Now we are moving towards stratus and nimbus. Shall we? Is this all right? So cirrus was a cloud that was forming at high altitudes, cumulus was at lower altitudes. Now we are moving towards stratus clouds, right? Now see, this is the stratus cloud. In this case, it is covering a huge area. So this is a cloud that covers maximum area, right? It is spread very equally, right? And it is at a lower height, right? So there are 3 important things that are happening here. It is at a lower height, it is spread equally, and it is covering maximum portion, right? And now, as we move towards nimbus, what we will see? So in nimbus cloud, now you will see a blackish color, right? This is the rain making cloud. So it will have blackish color, it will have shapeless clouds, right? And it is formed at the middle level, right? यहाँ पे भी हो सकता है, or near the surface, right? So there are 3-4 major aspects regarding it. First of all, there was cirrus clouds that are formed at high altitudes, right? And it is formed at high altitudes. It is very thin, it is very detached, right? It is having feather-like appearance. We move down, you will find cumulus clouds that are between 4,000 to 7,000. It is not having a very close together structure. It is cotton wool structure, but scattered clouds, right? Then we move towards the clouds that are having very even distribution, right? Very even distribution. They are spread equally, right? They are covering maximum portion, but at a lower height. These are stratus. And lastly, nimbus, the rainmaker clouds, right? Which are black in color and formed at the middle and near the surface. And these are, of course, providing us rain. All right. So these are the different types of clouds that you are going to see. Next is, let's look at a basic idea of all the, just a revision of a revision, right? So insolation, right, is creating what? So water is getting heated up, that is creating evaporation. This evaporation is rising up, and as altitude increases, temperature will decrease, leading to condensation, and then these small water droplets are then getting accumulated, forming precipitation, right? This is a very, very important aspect regarding our precipitation cycle that is happening in the atmosphere. All right. Now, the last aspect with respect to climatology of overall the world climatology, right, is the El Nino and La Nina phenomena, right? Again, we will make a table out of it and we will cover it properly, right? So, in case of El Nino and La Nina, what are some of the basic things that you can remember? It is happening between which 2 regions? So, it is happening between the South American coast and the Australian coast, right? First thing that you can remember. Now, there are a current system that you are going to see in the next few minutes. We are going to, when we are looking at the oceanographic section, there you will see some currents that are forming in this particular area, especially in the Southern Pacific region, right? So this is the region of Southern Pacific region. Which are some of the currents that you can remember? So in case of South America, around the coast of Chile, you will find Peru current, right? In case of Australia, you will find the East Australian current. Generally, what is their character? So, Peru current is cold and East Australian current is warm in character, right? But during the El Nino years, this cycle reverses, right? So, here what is happening is, generally what should be the condition? That the warm water should be seen in this particular area and cold water in this particular area, right? But here in the El Nino year, and this year it is being said that it is a super El Nino year, right? So, in this case, what will be the case? So, here you will find colder waters, and where the colder water should have been normally around the South American coast, there you will find warmer waters, right? So, when western coast of South America is having warm waters, it is known as El Nino, right? And La Nina would be the reverse of it, right? So, now this is a oscillation or a phase that is happening, right? It is a coupled phenomena, right? So, El Nino and La Nina are seen generally together only, right? So, that is why this whole this oscillation or this whole system is known as El Nino Southern Oscillation, right? So, it is a coupled phenomena of ocean and atmosphere, right? Where it is happening in the Pacific region, specifically in the Southern Pacific, right? Around which two major land masses? Around South America and Australia, right? So, basically there are three phases to this ENSO cycle. There is El Nino, where there is warming, right? In the case of La Nina, there is having colder temperatures, right? And in case of neutral ENSO cycle, there will be no changes, right? Now, in this regard, let's look at some of the basic differentiation between El Nino and La Nina. In the case of El Nino, there is unusual warming of Pacific waters, right? In which particular area? So, around the Chile coast, around the Peru coast, right? So, where the cold currents are flowing, there you are seeing warmer waters. So, that is why unusual warming, right? In case of La Nina, the unusual cooling is happening in case of Pacific waters near the Peru coast, right? Now, this is with respect to average temperatures. So, if it is warmer than average, then it is El Nino. If it is colder than average, then it is La Nina, right? Now, what is the temperature that we are talking about? So, when we are talking about 14 to 18 degrees Fahrenheit above average, it is El Nino. In case of La Nina, the temperatures drops more than 0.9 Fahrenheit, right? That is the amount that we are talking about than average, right? So, ocean temperatures are fluctuating in this particular area. El Nino's temperature is rising quite a bit, right? But in case of La Nina, it is not cooling as much, 0.9 Fahrenheit, all right? Frequency. So, there is no fixed schedule in case of El Nino, right? In case of El Nino, there is no fixed schedule. Generally, we are seeing it every 2 to 7 years, right? And La Nina, again, no fixed schedule. It usually follows El Nino, right? So, that is why it is seen together only, right? So, there is no fixed schedule, 2 to 7 years in case of El Nino, and then in case of La Nina, it is following the El Nino years, right? What is the duration? So, in case of El Nino, it is generally there for 9 to 12 months, right? But La Nina is able to be there for 1 to 3 years. So, there is a huge differentiation in that regard also, right? That 9 to 12 months is the case with respect to El Nino. 1 to 3 years is with respect to La Nina, right? Now, what will happen to rainfall and drought? Now, this is the portion where generally your questions are coming from, right? In this case, what is happening here? So, rainfall in case of El Nino, where would you see larger rainfall or heavier rainfall? It will be seen in Southern America, right? So, heavy rainfall in Southern America and drought in which particular area? Indonesia and Australia, right? Exactly reverse in case of La Nina, heavy rainfall in Australia and Southeast Asia, and where would you find drought-like conditions or very little rainfall? So, in Southern America, you will find drought-like conditions or little rainfall, right? So, El Nino and La Nina, it is a very similar aspect that is happening in case of Indian Ocean dipole also, right? So, in case of Indian Ocean dipole, that is a very similar phenomena that is you are going to witness in case of this particular area. So, there will be Australian coast and the African coast. A very similar phenomena is happening, right? what is here? Can anyone tell me which will be seen with respect to warmer and which one will be colder? Now, a similar condition is seen in case of the Indian Ocean region also, right? Here, in case of El Nino, what was happening? Here, there was unusual warming in the Pacific Ocean. In case of Indian Ocean dipole, there will be unusual warming in the western side, that is around the African coast, right? So, if it is warmer than normal, there will be more rainfall in this particular area, right? And cooler than normal in the Australian and Indonesian region. So, there you will be drought like conditions, right? Exactly, that is reversed in case of the negative phase, right, where there will be warmer than normal temperatures in the Southeast Asia and Australian region, right, and cooler than normal temperatures in case of East Africa, right. So this is positive and this is negative phase of the Indian Ocean dipole, which is having good effect on us. So it is quite obvious that the positive phase will have good effect on us and the negative phase is not having a good effect on us, right? In case of El Nino and La Nina, what are some of the impacts of El Nino and La Nina on India? So this can be asked straightforwardly. So in case of El Nino, it will cause weak monsoon winds. So you can also associate it with El Nino and negative IOD, right? So it will have, or it will cause weak monsoon winds, it will cause deficient rainfalls and droughts, right? It will cause warmer summers and it will affect kharif crops. Okay? In case of La Nina and positive Indian Ocean dipole, it will cause above normal rainfall, right? It will increase flood and cyclone risk, and if it is not excessive, it will lead to better crop yields, right? So this is the way you can remember these very important topics. All right. So now that we have already mentioned monsoon, we will come to the Indian climate, right? And we will start with the section with respect to monsoons. Shall we? अभी तक are you able to keep up? Is it productive for you? Are you learning something out of it? I'm hoping that most of these things you would have at least read once or twice before, right? And this is giving you a good revision out of all these topics, right? Now, in that regard, let's start with the monsoon winds, right? We have talked about it a little bit when we are looking at El Nino and La Nina and Indian Ocean dipole regions, right? So, what is it? So, basically, monsoon winds are nothing but seasonal reversal of winds. They are originating from, this term is originating from the Arabic word mausim, right, which means basically seasonal winds. Now, we are receiving two kinds of monsoon winds in this particular landmass, right. So, when it is coming from the southwest direction, so this is the southwest direction, right, when it is coming towards the western coast of India from the southwest direction, these are known as southwest monsoon winds, right. When it is retreating back, right, when it is retreating back, it is known as northeast monsoon. So this is northeast monsoon, this is southwest monsoon. In fact, it is such a distinctive feature of Indian climate that our whole climate is known as monsoon type climate, right. So it's a very, very important section. Now, when is it onsetting on the Indian landmass? So its onset is generally around which particular area? So it is around the 1st of June that it is onsetting towards us, right? Now, why is it that it is around this time period only that we receive the monsoon winds? So what are the mechanisms behind it? What are the reasons behind it? Why is it that our landmass is even receiving these winds, these seasonal reversal of winds, right? So first of all, the first aspect that you can remember is that during the summer months, when there is summer time period during the when we are looking at the summer months in the northern hemisphere, there are direct rays of the sun that are falling on the Tropic of Cancer, right? So these direct rays of the sun that is falling on Tropic of Cancer is doing what? Is heating up the land, right? Now, as temperature is increasing, pressure would decrease, leading to leading to the formation of intense low pressure zone, right? These are the things that we have already studied when we are looking at the previous section, right? So the all the things that you have already studied before, you are going to use it here and understand the monsoon rains, right? So first of all, during the summer months, the sun's rays are directly falling on Tropic of Cancer, right? Hence there will be increase in temperature leading to decrease in pressure. So there is a very important thing that is happening is low pressure zone is being created in the Indian landmass region. Now the next aspect is these summer months are also heating up the Tibetan plateau, right? Now this is a very important thing, right? Because Tibetan plateau is a huge area. It is the largest plateau in the world, right? And this huge area is a plateau is a flat surface. So it's a raised land with a flat surface, right? This huge area with a flat surface is getting heated up. Hence, this whole area is a huge low pressure area, and it is attracting winds from all sides, from the Pacific, from the northern regions of Asia, and from the Indian Ocean region also. So it is attracting winds from all sides. This is a huge area, a very large area of low pressure, right? Now, next important thing would be the ITCZ, right? Now, in case of ITCZ, there are important aspects. First of all, why is it called ITCZ? Intertropical Convergence Zone, right? What are converging here? Which winds are converging here? These are the trade winds, right? The tropical easterlies are converging here, right? Now, in that regard, because during the summer months, the direct rays of the sun are seen in this particular region, hence it is moving up, right? And it is even more the heating of the Tibetan plateau is having even more effect on it moving up, right? Or it is moving northwards. So as it is moving northwards, this intertropical convergence zone is properly in the Indian subcontinent. Now, because there is convergence of wind happening, because of heating up of the Tibetan plateau, because of the low pressure conditions that are seen in this particular area, what you will see is that this particular area is giving a lot of rainfall laden winds, and it is taking it towards the Indian subcontinent, right? So a lot of rainfall laden winds are moving towards the Indian subcontinent, right? As it is moving towards the Indian subcontinent, it is reaching the Kerala coast around 1st of June, right? After the monsoon season, when it is retreating back, so by the colder seasons, by the winter months, this ITCZ would have shifted downwards in the southern hemisphere. So there will be this particular area that is now attracting these winds. So hence you will see that during the colder months, when there is high pressure conditions in the Indian landmass, these retreating monsoon winds or northeast monsoon winds are moving towards the equator, right? This is a very, very important aspect, that these intertropical convergence zone is basically this low pressure zone that is being created due to what? Due to the direct rays of the sun falling on this particular area, and due to the heating of the Tibetan plateau, its intensity increases even more, right? Is that all right? Now, this is the differentiation between summer and winter time periods, right? So this is causing onset of monsoon, this is causing the retreat of the monsoon, right? Now, what are some of the basic aspects regarding the ITCZ? Because this can be asked like as a statement or as a question also, right? So ITCZ is a particular area of low pressure, right? During the warmer months, it moves towards the middle of the Indian subcontinent. Why? Because sun's rays are falling directly on the Tropic of Cancer. During the colder months, what is happening? The temperature is decreasing, hence there will be high pressure region, right, in the Indian landmass. So the sun's rays are falling on the Tropic of Capricorn, and hence it is the ITCZ is shifting towards the southern hemisphere. Hence the direction of the winds change, and it is getting reversed. That is why seasonal reversal of winds. That is the reason of monsoon, These are the most crucial aspects regarding these seasonal reversal of winds, right? So there are three things here. What is it? First of all, monsoon is the seasonal reversal of winds. Why is this seasonal reversal happening? Because during the summer months, there is an intense low pressure zone that is being created in the Indian landmass, right? That is attracting these winds, right? Due to the intense low pressure zone, what is happening here? So the ITCZ is shifting northwards, right? Because this is the region that is receiving the direct rays of the sun, right? Next important aspect is the Tibetan plateau is also getting heated up, right? So it is also attracting a lot of winds. So intensity is also increasing. And finally, when during the winter months, it is going towards the Tropic of Capricorn or below the equator, then it is retreating from the Indian landmass. All right. So this is a very important aspect. When are we receiving these monsoon winds? So it is being received around 1st of June in the Indian landmass around the Kerala coast, right? So entry is from the around the 1st of June, right? Now the next important thing that you can remember is that it is also setting around the same date when it is being received by Kerala at the Kerala coast. Around the same date, it is also being received in northeast India, right? So this is very, very important. Mizoram is also receiving at the same time when these winds are being received in Kerala. So 1st of June is seen in both the cases, right? Now, how is it that Mizoram is also receiving around the same time? Because when the monsoon winds are coming towards the Indian subcontinent, they are coming in two branches, right? One of them is Arabian Sea branch, that is providing rainfall towards to the Kerala coast, and the other is the Bay of Bengal branch, right? This Bay of Bengal branch is reaching the northeast India around the same time period. All right. So this is a very, very important aspect regarding the entry of the monsoon, right? If you look at the NCERT diagram, you can especially like directly see it. So for around the 1st of June, Kerala coast is receiving the entry of the monsoon. It is around the same time period that northeast India is also receiving rainfall, right? Especially around Mizoram and Tripura region, right? So this is very important for you to remember. This is not written in our books, but it is shown in the NCERT maps. That is why it becomes very important, and it is covering the whole of the Indian landmass by 15th of July. So the advancing monsoon is able to cover from 1st of June to 15th of July the whole of the landmass. Retreating monsoon starts retreating by 1st of September, again from the core regions of the Thar Desert, and it moves downwards, and by 1st of December it is leaving the Indian landmass, right? So it is onsetting on 1st of June in Kerala as well as northeast India, right? And it is retreating from 1st of September to 1st of December. So retreating is taking more time than advancing monsoon, right? That also becomes a question, right? Now, what is the difference in seasonal and annual rainfalls in case of India, right? So if you look at the annual and seasonal rainfall, what you will see is a particular area that you will have to remember. Some basic things is quite clear for all of you, that which are the areas that are receiving the most amount of rainfall. It is the Western Ghats and the Northeast Indian region, right? But a specific thing that you can remember is during the monsoon months, this area is receiving quite a little rainfall, right? Not as much rainfall is being received by the Tamil Nadu coast, but overall in case of annual rainfall, this is quite a bit rainfall is seen in case of Tamil Nadu coast. So how is it that even though Tamil Nadu coast is not receiving as much rainfall during the monsoon months, it is having annual rainfall is all right? The reason is, if you see properly here, it is receiving rainfall from the retreating winds, right? And that is its connection, and that is also its connection with respect to Kaveri river also. So Kaveri rivers, the upper portion is receiving rainfall from advancing monsoon, and lower portion is receiving rainfall from retreating monsoon, right? So this is a very important aspect, that Tamil Nadu coast is receiving a lot of rainfall from retreating monsoon. That is the reason that you will find that overall rainfall is all right, but when you are looking at seasonal rainfall in case of Tamil Nadu coast, that is not the case, right? So these are some of the basic aspects. Of course, monsoon season is having its own effect, right? It is, of course, the creation of low pressure zone in our region, right? and as it enters India, it is able to cover the whole of the Indian landmass from 1st of June to 15th of July. There are two branches, Bay of Bengal and Arabian Sea branch, right? Now, what is the rhythm of seasons in case of India, right? Now, this becomes a bit important for you, right? So, let's look at from the starting of our year, right? When we are starting our year, there is generally cold weather season, right? So, in cold weather season, temperature is less, pressure is high, right? That is why we have seen the retreating monsoon. Next, as we move towards the hot weather season, temperature rises and pressure falls. This is attracting the winds from across the equator, right? Then, as these southwest monsoon winds are being attracted here, what is the condition in the Indian landmass? There is low pressure condition, right? So that is why there will be rainfall in the Indian subcontinent, right? And when the winter season is now arriving again, what is happening? There is, because of temperature dipping, there is high pressure, same condition that you had seen. Hence, what you will see is there is retreating monsoon because the ITCZ has shifted below the equator, right? So this whole rhythm of season keeps on happening. So from cold weather where there is high pressure in the Indian landmass to the hot weather seasons and during the monsoon months, there is intense low pressure, and that is attracting the monsoon winds towards the Indian landmass. All right. Next important aspect is that when this when this monsoon is being received by the Indian landmass, it is not happening gradually, right? This is very important, that this monsoon or the rainfall is received very abruptly, right? So there is a sudden onset of monsoon, right? It is very, very important aspect, right? Next important thing that you can remember is that Arabian Sea branch is associated with orographic rainfall, right? It is due to the orographic rainfall that Western Ghats is receiving so much amount of rainfall, right? What is orographic rainfall? Though the monsoon winds that are coming in this particular direction are being obstructed by the Western Ghats, right? And as the Western Ghats are having quite a bit of elevation, the monsoon winds have to rise up, and as they are rising up, what is happening? So the altitude is increasing, temperature is decreasing, the water vapor is being formed, right? They are forming clouds, and then they are the rainfall is happening in the Western Ghat region. So this becomes a bit important for you, that orographic is rainfall is seen in case of the western, in case of the Arabian Sea branch of the monsoon. All right. Next important aspect is what these particular branches are having particular effects in particular areas. So if you see the branch that is associated with the Arabian Sea branch, right? It is being obstructed by the Western Ghats, hence orographic rainfall we have seen, right? Then as it moves towards the Mumbai region, right, it is giving rainfall in the central Indian region. Why? Because then it is being obstructed by Vindhyan and Satpura range, right? So there is the Western Ghat region, the Mumbai region, that is giving rainfall to the central Indian region. But in case of this particular area, this whole area of northern Gujarat and Rajasthan region, especially around the western Rajasthan region, the Aravali range are lying parallel to the direction of the Arabian Sea branch of the southwest monsoon. Hence, because there is no obstruction, right, there is very little rainfall in this particular area, right? But in case of now we are seeing the Bay of Bengal branch. Now it is reaching the northeast India around the same time, right? First of all, the coast of Myanmar and Bangladesh are receiving a lot of rainfall. Then as it moves up, the Arkan Huma hills deflect it towards the Indo-Gangetic plains, right? So there is an Arkan Huma mountain range. I am hoping that you remember, or that you have a basic understanding, that even our Andaman and Nicobars are an extension of this particular mountainous region, right? So this Arkan Huma hills deflect it towards the Indo-Gangetic plains, and this is then causing the rains in the northern plains region, right? So this is a very, very important aspect about these two branches, right? So it is having orographic rainfall in this particular region. The Vindhyas and Satpuras are also making the rain, giving the rainfall to the central Indian region. But because Aravali range are lying parallel, they are not able to receive rainfall in this particular area, right? In case of the Bay of Bengal branch, the Arkan Yuma mountain range are one of the important reasons due to which the northern plains are receiving a lot of rainfall, right? Now, in case of distribution, how much is our average annual rainfall? It is around 125 centimeters, right? But there are spatial variations also. So, some regions like Western Ghats in Northeast India receive a lot of rainfall, over 200 centimeters, right? Some regions receive medium rainfall, right? That is which region? So, this is majority of the country, right? Southern Gujarat, East MP, Bihar, Jharkhand, Odisha, East UP region, these are receiving medium rainfall. And then there are regions where it is very little rainfall, 50 to 100 centimeters, that is Rajasthan, Punjab, Haryana, right? The Jammu and Kashmir, Western UP, Deccan, these are the regions with little rainfall. Of course, below 50 centimeters is a very arid region, right? So, below 50 centimeters would be very, very arid region, arid and semi-arid region. So, there are regions, there are two important regions that are associated here. It is the rain shadow region of Western Andhra, Northern Karnataka and Eastern Maharashtra, right? Then there is the Thar desert, right? Especially the Western Rajasthan region, right? That is receiving such a low amount of rainfall. And then Ladakh is also receiving very little rainfall, right? Snowfall is generally restricted in case of the Himalayan regions only, right? So, snowfalls is seen in case of Himalayan regions. All right. Now, the last aspect, if I can, yeah. So, this is the last aspect, that is some of the local storms. Now, these are names that you would have heard or read, at least I am hoping that quite a few times. We'll just look at some of the basic things about them. So, these are short duration, small weather phenomena, right? Key characteristics would be that it is having limited geographical extent, shorter duration, high intensity and seasonal occurrence, right? Now, in that regard, which are some of the important local storms that you have seen in India? So, there is Lu, right? Where it is flowing? It is flowing in the northwest Indian region, in the Indo-Gangetic plains. When? It is during these months only, right? During the summer months from May to June, right? Generally around the afternoon time. In case of Andhi, these are dust laden winds. Again in North India, these are pre-monsoon, these are seen generally in the pre-monsoon evening regions, right? So, these are Lu and Andhi. Next would be the important local storm of Kal Baisakhi. It is seen in West Bengal, Assam, Bihar regions. These are violent thunderstorms, right? They bring heavy rain, strong winds and lightning, and they are beneficial for crops like jute and tea, especially that is seen in this particular region. Especially jute crop is quite a bit big beneficiary of this Kal Baisakhi. This is also known as nor'westers, right? Next is there is mango showers in the region of Kerala and Karnataka. These are again pre-monsoonal rainfall and they will help in the ripening of mangoes, hence the name mango showers, right? Last one that we can remember is blossom showers, right? Again seen in Kerala Karnataka region, it will help with the blossoming of coffee flowers, right? So, these are some of the local storms that are seen in India, right? Lastly, there are some climatic regions that are associated with India, right? In that regard, which are some of the major climatic types of India? So, there is the tropical region, where what would you see? So, there is mean monthly temperature all around is above 18 degrees Celsius. Otherwise, there is dry climate, warm temperate, cool temperate and icy climates, right? These are associated with particular areas of India, right? If you can remember this particular aspect, well and good. If not, it has not been asked till now, right? But what you can remember is, say for example, this particular region, right? So, this is very, very hot desert region, and just in the transition region, just after this hot desert region, you will find steppy type of climate, right? So, this you can remember that in the transition zone after the desert region, you will find steppy region. This same steppy region is also found in the rain shadow area in southern India, right? So, steppy climate and steppy climate are seen in two particular regions, right? That can be one of the questions. Next is there is tropical savannas that are seen in the next section, that is just below the Tropic of Cancer, but not as dry as the steppy regions. So, there is steppy as well as savanna, both are seen in this particular area, right? So, these are some of the important things that you can remember, right? So, this covers our section with respect to climatology of both the world section, the physical geography section, as well as the Indian section. All right. Let's look at the next topic now. Shall we look at the next section? That is oceanography, right? Now, we have completed geomorphology section and climatology section. In the climatology section itself, we had also looked at some basic aspects regarding the monsoon or Indian climate, right? Now, we are moving towards the oceanography section, right? Here, we are going to focus on 3 or 4 major areas. These would be, first of all, ocean temperatures, ocean salinity, right? Horizontal and vertical distribution of temperature and salinity. Then we will move towards ocean currents, and at last we will see the exclusive economic zone and territorial waters. So these are our focus areas with respect to oceanography. Let's start with the distribution of temperature in ocean waters, right? What are some of the basic things that you can remember here, right? So first of all, if you would remember that the earth was absorbing, right? The earth was absorbing insolation, right? Now it was absorbed by land as well as sea, right? We know what was the effect of the heat that was being absorbed by land, right? We have already covered it in our climatology section. Now we are moving towards the insolation that was being absorbed by the sea, right? Now we know when we are looking at the land breeze and sea breeze that specific heat of water is higher, right, than land, right? In that regard, let's look at this specific heat specifically. So in case of specific heat, what are some of the basic things? This is the amount of heat required to raise the temperature of a substance by 1 degree Celsius, right? So if we are saying that water has higher specific heat capacity, it means that it will require more heat to raise the temperature of water by 1 degree Celsius, right? In comparison to, of course, land, right? That means it will heat up slowly and cool down slowly, right? So this is a very, very important aspect, right? That the specific heat of water being higher means it will take time to heat up and it will take time to cool down. That is why when we are looking at the land breeze and sea breeze section, so during the daytime, sea was cooler in comparison to land, and during the night time, sea was hotter in comparison to land, right? In case of land, it is exactly reverse, right? It warms up quickly, it cools down quickly. All right. So this is the specific heat. Now, in case of horizontal distribution of temperature, this is a very basic aspect that if you are looking at the latitude itself, what is happening here? So temperature is decreasing as we move towards the poles. So around the equator, it is the highest. Average temperature is around 27 degrees Celsius. As we move towards 20 degree north and south, around somewhere around the tropics, right? So it is coming down to 22 degrees Celsius. Around the 40 degree north and south latitudes, it is around 14 degree Celsius average temperatures, and around the poles, it can reach as low as 0 degrees Celsius, right? So rate of decrease here is with respect to latitude. Per latitude, there is 0.5 degrees Celsius decrease, all right? So this is with respect to horizontal distribution in context of latitude. Now, there is also a spatial distribution, right? So in northern areas, in the northern hemisphere, you will find more land is there, right? Now we know that land gets heated up quickly and water takes time to heat up, right? So because northern hemisphere has more land, it has higher average temperatures, right? The reason being that it has more land than southern hemisphere. Southern hemisphere has more waters, right? So it has lower average temperatures, right? This is a very important aspect. And what is the average temperature of northern hemisphere? It is 19 degrees Celsius. In case of southern hemisphere, overall it is 16 degrees Celsius. Is that all right? So there is a differentiation with respect to hemispheres also, right? So this is a very, very important aspect, that with respect to latitude as well as hemispheres, there is a differentiation. Now, as we move towards the vertical distribution of temperature, right? Now, this will be about what particular aspect? So here there is a decrease in temperature with increasing depth, right? Now we are going to explore how is this decrease happening, right? Now, in case of, say, for example, latitudes, we have already seen that as you are moving from equator to the poles, there is a steady decrease and it is around 0.5 degrees Celsius. Is that the case with respect to the depth also? Is that the case with respect to vertical distribution also? Let's see. So, this rate of decrease in temperature is not uniform, right? It is not uniform. It falls very rapidly in a particular zone, right? Now, let's look at what is this zone all about and how we can explore it, right? This is a very, very important diagram for you to remember, right? If you can remember this, this will really help you with many important sections, right? First of all, this is the axis with respect to depth and this is the axis with respect to temperature, right? When we are seeing this first layer, right, this is the warm oceanic layer. Here insolation is being received, it is being absorbed, right? So, this layer, the first layer, the temperature is ranging between 20 to 24, 25 degrees Celsius, right? So, here temperature is almost uniform between 20 to 25 degrees Celsius, right? It is the top layer, it is the warm oceanic layer, right? How much is the depth? So, the depth is around 0 to 200 meters. It's a very, very top section of the ocean waters, right? Only sometimes it can go up till 500 meters, but generally it is between 0 to 200 meters. So, from sea level, 200 meters is the depth, right? This is the first layer. Here the temperature is around between 20 to 25 degrees Celsius. It's quite warm temperatures, right? Now, this is the next and very, very important layer. This is the layer called thermocline, right? This is the layer called thermocline. This is ranging between how much? So, it is between 500 to 1000 meters, right? This is between 500 to 1000 meters in depth, right? Now, this is a transition from the warm surface waters to colder or deeper ocean waters, right? So, this is a transition zone. But here what you are seeing is that there is a rapid decrease in temperatures, right? There is a rapid decrease in temperatures, right? So, this is very important that it is in the thermocline layer that you will find that there is a rapid decrease in temperature, right? In fact, after this layer, there is 90% of ocean waters is seen after this layer. So, it is still very surface level water only. It is just below the warm ocean waters, right? But this layer is very crucial. This is the thermocline, right? And here you will see rapid decrease with increasing depth. All right, this is an important section. Next, when we look at the last layer, that is the third layer or the deep ocean waters. So, these are generally very cold waters, right? These are generally very cold waters. It will extend up to the ocean floor, right? So, it will extend up to the ocean floor. In some areas, because we have already looked at the horizontal distribution. So, in some areas, when we are looking at the pole regions, it can go as low as 0 degrees, right? But average temperatures is around 0 to 4 degrees Celsius. It is uniform in character, right? So, it is uniform in character. That is the third layer, where we are looking at the temperatures that are very, very cold but uniform in character. All right. So, this is with respect to the distribution of temperature horizontally as well as vertically. Now, we are moving towards salinity, right? Now, in case of salinity, what is the first important aspect? So, in case of salinity of ocean waters, you will see that here, what is salinity that we are talking about? First of all, very basic aspects. So, it is the total content of dissolved salts in seawater. Basically, the amount of salt per 100 gram of seawater, right? That is why it is expressed as parts per thousand, right? So, parts per thousand of seawater, right? And which are these salts that we are talking about? These are mostly, if you are looking at majoritarily, it is sodium chloride 77% and magnesium chloride around 10%. There are other salts also, but the most important ones are these two in character. All right. Now, if you look at the salinity of ocean waters, so what you will find is a very important correlation that you can remember is that where temperatures are higher, the evaporation will be higher, and where evaporation is higher, salinity will be higher. So it is in the hot, dry regions that this particular correlation is very, very effective, right? In that regard, we'll look at some horizontal distribution also and vertical distribution also, but it is this particular correlation that you can properly remember, and that will help you remember other aspects also, right? So if there are regions where there is a lot of influx of fresh water, there are a lot of rivers, the salinity will be lower, right? If there are regions where there is a lot of rainfall, the salinity will be a little bit lower because it is receiving fresh water. And in hotter regions, in drier regions where it is not receiving as much fresh water, in that case salinity will be higher, right? In that regard, now let's look at the horizontal distribution of salinity in ocean, right? Here very basic aspects we are seeing. So we are looking at equator, subtropical region and poles region, exactly how we had seen the previous topic. So in this case, what we are seeing is equator, that is between 0 to 10 degrees north and south, there is high rainfall and hence there will be lower salinity, right? There is high rainfall in the equatorial region, right? That is why here you will see equatorial rainforest, and rainwater is fresh water in character, right? Now, where would you find the highest salinity? You will find it in subtropical regions between 20 degree to 30 degree north and south latitudes, right? Here evaporation is high but rainfall is low, right? So because the evaporation is high and rainfall is low, in this particular region you will find the zone of highest salinity. And in the poles, due to the melting of the ice, right, and lower evaporation, it will have lowest salinity. So zone of highest salinity is in subtropical regions, lowest salinity is in the polar regions. Equator is having high rainfall, high temperature but high rainfall, and hence it is lower salinity, not highest, not lowest, lower salinity. All right. So this is with respect to horizontal distribution of salinity. Now, in case of vertical distribution, again there are three layers here, right? In this case, there are three layers here. Which are these layers that we are talking about? There is the first layer where you will find again the surface layer, same thing that we have seen there. So this is again between 0 to 200 meters. In this regard, there is high variability, right? Now, why is there high variability in the surface layer itself? What is happening is, again, it is being influenced by evaporation, precipitation and river inflow, right? In that regard, what is the basic concept here that you can remember? So wherever there will be an influx of fresh water, the salinity will be lower, right? So if there is melting of ice or freezing of ice, if there is more river inflow or less river inflow, if there is a lot of rainfall or less rainfall, if there is a lot of evaporation or less evaporation, it will have a direct effect, and hence this is a zone of high variability, right? So loss of water due to evaporation and ice formation can also cause changes in the salinity of oceans, right? So in subtropical regions there is high salinity, and around the equator and the poles there is low salinity. What is the reason again? So in the subtropical regions there is higher evaporation, but there is also higher salinity. In case of equator, you will find that there is high evaporation but also high rainfall. So there is influx of fresh water. In case of poles, there is melting of ice going on, so lower salinity. So you are connecting both the horizontal and vertical distribution aspect here, right? So in this first layer, there is very high variability, right? Now, as we move towards the next layer, that is the halocline, right? In case of temperature, there was thermocline. Here there is halocline between 200 to 1000 meters, right? Again, this is a transition layer between surface waters and deep oceans, right? Again, the salinity will change rapidly with depth, right? But what are some of the things that you can remember? So again, you will see that in the subtropical regions, it will decrease with depth, right? the salinity will decrease with depth. In the polar regions, it will increase with depth, right? So salinity, as we are going down the ocean towards the ocean floor, it is decreasing here, है ना, with depth. In case of polar region, it is increasing with depth. This is very, very important. It can come as a statement. All right. So this is the layer of the halocline. Again, there is spatial variation also here, right? And the last one, that is in the depth, right? Again, this will be much more uniform, much more stable, very similar to what we have seen in the case of temperatures. Here, the depth is above 100 meters, above 1000 meters, right? Here there is little influence, very little influence of surface waters that is seen in the case of the first two layers, right? So at such depth, there is very little water loss or addition of salt, right? So in that case, it is almost uniform and stable, right? This kind of area is, in this kind of area, the salinity is quite uniform and stable, right? Hence, in this particular area, there is much more uniform characteristics are found. All right. So this covers our section with respect to the temperatures as well as the salinity of the oceans. Now we are moving towards the next one, that is the ocean currents, right? Now, this is, for some people it is very easy to remember, for some they find it very, very hard. If you look at this properly, there are some of these circular gyres that you are seeing, right? If you are able to remember these circular gyres, right, you will be always be able to remember these warm or cold ocean currents, right? Some basic aspects. So whichever current is touching or coming from the equator region, they are generally warm in character. Whichever are coming from the polar regions, right, they are generally cold in character. Just a basic rule of thumb, right? Now, in this case, what you are going to find is, first of all, what is an ocean current? So it is a continuous flow, right? It is a continuous flow of a huge amount of water in a definite direction, right? So these are like rivers flowing in oceans, right? So there is a continuous flow in a definite direction. Those are called currents, right? In that regard, there are two types or two major forces that are applied here, right? So here there are some primary forces that will affect it, and then there are some secondary forces that will affect it. In the primary forces, you will see insolation, wind, gravity and Coriolis force, and in the secondary forces, you will see temperature, salinity and density, right? So in that regard, let's look at the first aspect. First of all, how is this process of current formation going on, right? So here what you will see is the heating causes the water to expand, right? The heating of the ocean waters causes the water to expand. Now, winds blowing on the surface now pushes this water to move, right? So it is the winds that are creating these ocean currents. That becomes really important for you to remember, right? Now it is pushing the water to move and gravity is trying to pull it down. Hence what you will find is, through this particular mechanism, and of course the Coriolis force that is always applied on fluids that are flowing on the Earth's surface, right? It will flow towards the right in the northern hemisphere and towards the left in the southern hemisphere, right? So there is heating or insolation that is making the waters expand, that is causing the waters to heat up and expand. Then the winds are making these move, gravity is pulling it down, and Coriolis force is making it move in a particular direction, right? Is this clear, this whole mechanism? Now, there are some aspects such as there is vertical mobility and there is horizontal mobility. Now, in this case, what is happening with respect to ocean waters? So here, denser water sinks, right? And lighter water rises. This becomes very important. So we have seen that highly saline water is denser and it sinks, and lighter saline or less saline water, that is lighter, is rising up. Now, the next aspect that we can look at is, on the basis of depth, how we are dividing these currents, right? So on the basis of depth, there are some surface currents, that is reaching up to 400 meters, right? This is just 10% of the ocean waters. But there are deep ocean currents that are deeper than 400 meters, right? That is constituting 90% of the ocean waters. right? So it's very, very important that where would you find more waters, what are these aspects with respect to depth that we can see. Now the next aspect is, of course, there are two major types that is what we are going to focus on today, that is warm water currents and cold water currents, right? Isme, if you have to just remember one thing, if the current is moving from the equator towards the poles, it is generally warm. If the if the current is moving from the poles towards the equator, it is generally cold, right? This is something just as a almost like a shorthand thing that you can remember, right? Now, what we are going to do is we are going to look at gyres, and through these gyres we are trying to remember these major oceanic currents, right? So we are going to focus on North Atlantic and South Atlantic gyre, North Pacific and South Pacific gyre, right? So these gyres are large accumulations of water, and around these you will find these currents, right? So now, what is the direction of these gyres flow? So in the northern hemisphere, again it is clockwise direction. In the southern hemisphere, it is anti-clockwise direction, right? Now let's look at the major ocean currents and their gyres. So we are going to focus on Pacific and Atlantic. If you are able to remember this, this is very good enough. Then this particular section is, of course, our very easy thing. So this is quite easy to remember, but these four gyres are very important, right? In that regard, if you look at a basic differentiation or diagrammatic representation, so there are some important currents that you can remember. So on the western coast of North America, there is Alaska current that is warm, and there is California current that is colder, right? Between North America and Europe, there is North Atlantic drift that is warm, right? And there is Canary current that is cold, right? Now this North Atlantic drift you will see is moving on from the Gulf Stream itself, that we are going to remember. Between North America and Asia, there are no ocean waters, it is connected land. But in the Pacific Ocean, you will find around the Japanese coast, there is Oyashio cold current and Kuroshio warm current, right? So this is in the northern hemisphere. Now, as we move towards the southern hemisphere, you will find that in Latin America or South America, there is Brazilian warm current and Peru cold current. Near Africa, you will find which one? Benguela cold current and Algolas warm current, right? Now we are coming into the Indian Ocean region, right? So in Australia, you will find West Australian current. This is colder current, and East Australian current, that is warmer current. This was the connection with East Australian current and Peru current that we had seen in case of El Nino, right? In case of El Nino, La Nina, that we have already seen, right? In that regard, let's look at some of the gyres, and we are just taking a basic look at it, and then we'll move forward, right? So in this case, in the North Atlantic gyre, if you are looking at this particular section, this is the equator, right? And here you will find the North Equatorial current. So as we move towards the North American region, there is Gulf Stream. This is around Mexico and Caribbean Islands, and then Gulf of Mexico and Caribbean Islands. And then as we move up, there is North Atlantic drift. This is both warm current as it is moving up from the equator, and there is this extension of North Atlantic drift that is moving on to the Scandinavian regions, where there is Norwegian warm current. This is one of the reasons that people are able to live such high up in the around the Arctic Circle, right? So Norwegian current is very, very important. Now, as we move towards the European section, right, there is a Canary current that is colder current, right? So this is the North Atlantic gyre. Now, in the South Atlantic gyre, what you are seeing? So again, there is this South Atlantic current, right? There is South Atlantic current. Then as we move towards the African region, you will find Benguela current towards the western coast of Africa. Then as we move towards the equator, you will find South Equatorial current. Again, it is warm current. And then as this South Equatorial current move towards the South American region, towards the Brazilian coast, you will find Brazilian current, that is warm current, right? So this gyre you can remember with respect to South America and Africa, and there are these currents that are warm, that are coming from the equator are warm, and as it moves up from the poles, it is colder in character. Now in case of North Pacific gyre, right? So in case of North Pacific, one of them we have already seen Oyashio and Kuroshio. Oyashio is coming from the poles, so colder, and Kuroshio is warmer in character. Then there is North Pacific current, right? Now it is moving towards the poles, right? Here it is moving towards the poles, but it is taking its waters from the Kuroshio current, right? So it is still warmer in character, right? Next, it will move towards the Alaskan region, right? Again, warmer in character. That is why people are able to sustain, at least some people are able to sustain in some of these regions, right? And as it moves towards the western coast of North America, there is California current that is cold. Now, Alaska is generally very cold climate, but the current is warmer, right? California is generally very warm climate, but the current is colder, right? So there is a reverse relationship here that you can remember. This is of course the north equatorial current that is flowing around the equator, right? Lastly, this is the South Pacific gyre. So if you take it from the equators itself, so there is South equatorial current that is warm. Next, it is moving towards the East Australian coast, that is East Australian current, that is again warm. As it moves towards the poles, so there is South Pacific current that is cold, and as it moves towards the western coast of South America, the Peru current or Humboldt current is colder in nature, right? These are some of the most important aspects. Now we are coming to the Indian Ocean gyre, right? Now here what you see is India is right in the middle, right? That is one of the reasons the primary position of India in this region is giving it its name, right? Indian Ocean. So here you will find South Equatorial current, right? Now towards the eastern coast of Africa, there is a warm current by the name of Algolas, right? Then as we move towards the Antarctica region, you will find South Indian current, right? And as we move towards the West Australian region, right? You will find West Australian current, that is colder current, that is because it is rising up from the poles, right? So this is the Indian Ocean gyre, right? This is all the major currents that you must have a basic understanding about, and of course its connection with our climatology and Indian monsoon section, right? Last thing that we have to remember is that how much is the territorial waters of the country and what is the exclusive economic zone of the country. So it is getting its definition from United Nations Convention on Law of the Seas, right? UNCLOS definitions, right? Up till 12 nautical miles, you will find that it is called the territorial waters of any country, right? The country can do anything in this particular area, right? Then from this particular area, from the baseline till 200 nautical miles, right? So 12 nautical miles is the territorial waters of any country. Up till 200 nautical miles is the exclusive economic zone of a particular country. So these are not its territorial waters. A country is not free to do anything in this regard, right? A country cannot stop any other country from coming in this particular region. But what is the most important thing that you can remember is that they are able to use it exclusively as their own economic zone, right? That is one of the very big reasons that there is disputes of South China Sea. There is disputes regarding, say, for example, Sir Creek. There are a lot of disputes, especially around the sea regions, because of this particular aspect, right? So exclusive economic zone is up till 200 nautical miles. Territorial waters is up till 12 nautical miles. All right. These are getting its definitions from the UNCLOS. All right. So this is very, very important. This you can remember. After this, the high seas will start. All right. So these are some of the very important sections with respect to oceanography from this particular area. So this covers all the major sections of our physical geography, right? Geomorphology, rocks, minerals, landforms, climatology, Indian monsoon section, as well as the sections which are related to our oceanography, right? So this, I'm hoping that after this session, you are feeling much more better revised about physical geography section. What I can suggest you from my side is, because these are theoretical elements, but they have a reasoning to them, right? This happens, hence this happens, hence this happens. See the number of times we were looking at different flowcharts through which we could understand some of the major and very crucial topics, right? So even in exams, do try to apply logic and reason to your answers, right? Because UPSC has a very, very old habit of trying to trap you in the verbose language of the questions, right? So I'm hoping that your preparations have been very well, right? From my side, I can just suggest you and give you some basic tips that do try and maintain your speed, right? Do try and answer at least that many questions, at least a number of questions that you are comfortable with respect to the first reading. Then go for some of the speculative bits of where you are able to eliminate some questions in the second reading. And finally, if the questions are done well, then go for a third reading and look at some of the basic revision aspects of the question paper. All right, that is all for today. Thank you so much and wish you all the very best for your exams. May God bless you. Thank you so much.
For more informative content, like, share and subscribe, and do not forget to press the bell icon to get the notifications.